the universe never began. What if everything you've been told about our cosmic origins is fundamentally flawed? Not just incomplete, but profoundly, cosmically wrong. You've heard it countless times. 13.8 billion years ago, an infinitesimal point exploded outward, creating all of space and time in a cataclysmic event we call the Big Bang. It's a comforting story, a clear beginning, a definitive moment of creation. But what if the Big Bang did not bang? What if our universe never truly began at all? Close your eyes for a moment. Imagine rewinding the cosmic film reel of existence. Galaxies rushing backward, stars imploding rather than exploding, space itself contracting into an ever denser, ever hotter state. Convention tells us we eventually reach a singular point, a cosmic egg containing all matter, energy, space, and time. But what if, instead of reaching this mythical time zero, we encounter something far more disturbing? A threshold beyond which our very concept of before disintegrates. You exist in a universe that may have no beginning. Let that thought settle into your mind. Feel its weight, its staggering implications. We humans are storytellers by nature. We crave narratives with clear beginnings, middles, and ends. Yet, the cosmos refuses to conform to our narrative instincts. It offers no easy answers, no comforting origin myths that withstand deep scrutiny. Just endless, unsettling questions. Some cosmologists now suggest that what we call the Big Bang was not the beginning, but merely a transition, a phase change in an eternally existing reality. Picture the surface of a frozen lake beginning to thaw. The transition from ice to water is dramatic, transformative, but it doesn't mark the beginning of the lake's existence. Similarly, our universe may have simply shifted states from something utterly unlike what we know to the expanding space-time we inhabit today. But I'm getting ahead of myself. Before we venture into these cosmic waters, let's acknowledge the vertigo that comes with questioning our most fundamental assumptions. The ground beneath your intellectual feet is about to shift dramatically. Are you prepared to let go of cosmic certainty? You might wonder why it matters. This question of beginnings. You exist now, after all. Your coffee still steams in the morning, traffic still jams, children still laugh. But consider this. If we've fundamentally misunderstood how existence itself came to be, what else might we be wrong about? If our creation story crumbles under examination, what other pillars of understanding might also collapse? The stars you see at night? Those ancient pinpricks of light that have guided sailors and inspired poets. They're messengers from a past we barely comprehend. When we gaze at Andromeda, our nearest galactic neighbor, we're seeing it as it was 2.5 million years ago. The light now reaching your retina began its journey when our ancestors were still learning to fashion stone tools. You aren't just looking at stars. You're looking backward through time itself. But even this mind-bending perspective is just the beginning of our journey into cosmic uncertainty. If we could somehow accelerate beyond the speed of light, an impossibility according to Einstein, but indulge the thought experiment and outrace those ancient photons, what would we see? Would we witness the birth of the universe? Or would we encounter something far stranger? A cosmic landscape that refuses the very concept of a beginning. For nearly a century, we've been told that time itself began with the Big Bang. Before that first moment, this is the conventional wisdom, there was no before. Time simply did not exist. But this explanation has always contained a paradox. How can something begin if there was no time in which beginning could occur? It's as if we've built our entire cosmological framework on a logical impossibility, a cosmic sleight of hand that distracts us from deeper questions. Imagine standing at the North Pole. Every direction you step is south. There is no further north to explore. Not because of some boundary or wall, but because the very concept of north breaks down at that location. Conventional cosmology suggests time behaves similarly at the Big Bang. There is no before, not because something prevents us from looking further back, but because the concept itself disintegrates. Yet this analogy, elegant as it may seem, merely sidesteps the question. It doesn't resolve the paradox of beginning, it simply declares it off-limits to inquiry. And human curiosity has never respected such boundaries. Now consider another possibility, one that's gaining traction among theoretical physicists. What if our universe is just one cosmic inhalation in an infinite cycle of expansion and contraction? Imagine the universe as a lung, eternally breathing, expanding outward, then collapsing back in on itself, then expanding again. In this cyclical cosmos, the Big Bang wasn't the beginning but merely a transition point, a cosmic rebirth after a previous universe collapsed into itself. This idea, known as the cyclic or oscillating universe, has ancient roots. Hindu cosmology has long envisioned cosmic cycles of creation and destruction playing out over trillions of years. Modern physics may be catching up to intuitions first voiced millennia ago, but even this model eventually crashes against a wall of paradox. Can anything truly be eternal? Can cycles continue indefinitely without degradation? The second law of thermodynamics suggests that disorder always increases over time. How, then, could a cycling universe maintain itself forever? Perhaps we're still thinking too linearly, too bound by our human perception of time as an arrow flying in one direction. What if time itself is more complex, branching, looping, or even fractal in nature? What if our universe is part of a vast multiverse, a cosmic foam of realities constantly bubbling into existence, each with its own physical laws, its own version of time, its own peculiar existence? You may feel a creeping vertigo at this point, a sense that the intellectual ground beneath your feet is giving way. That's natural. Even the most brilliant physicists and cosmologists experience this sensation. We're probing the very edges of human understanding, where mathematics becomes our primary tool and intuition often fails us completely. Let's step back for a moment and ground ourselves in what we actually observe. When astronomers look outward, in space, which is simultaneously looking backward in time, they see something remarkable. Everything is moving away from everything else. Galaxies aren't just drifting through static space. Space itself is expanding, stretching like the surface of an inflating balloon. Trace this expansion backward, and all matter seems to converge toward a common point. This observation, first made by Edwin Hubble in the 1920s, provided the empirical foundation for Big Bang cosmology. It seemed incontrovertible proof that the universe had a beginning. But observations can be interpreted in multiple ways. The expansion we observe tells us that the universe was once in a hotter, denser state. But it doesn't necessarily tell us that this state was the beginning of everything. Consider this disquieting thought. What if the apparent convergence toward a beginning is an illusion created by the limitations of our observational tools? What if, as we approach what we think of as the beginning, the universe doesn't actually contract to a point, but transforms into something our current theories cannot describe? Some physicists suggest that at extremely high energies and densities, the conditions of the very early universe, space and time themselves, might dissolve into something more fundamental, a quantum foam where the familiar laws of physics break down completely. In this realm, concepts like before and after might be as meaningless as asking what's north of the North Pole. String theory, loop quantum gravity, causal set theory. These are mathematical frameworks attempting to peer beyond the veil of the Big Bang. Each suggests, in its own way, that what we consider the beginning might actually be a boundary between different phases of existence. Not the beginning of everything, but the beginning of everything as we currently understand it. But these theories remain speculative, mathematical universes that may or may not correspond to physical reality. We've reached the limits of not just what we know, but what we can know given our current technology. We can detect the cosmic microwave background radiation, the afterglow of the Big Bang, but we cannot directly observe what came before it. This is perhaps the most humbling aspect of cosmology. We may be fundamentally limited in our ability to answer the most profound questions about existence, not just temporarily limited by current technology, but permanently bounded by the physics of observation itself. There are horizons beyond which we cannot see, not because something is blocking our view, but because the information from those regions can never reach us. You might find this frustrating, this cosmic uncertainty principle. Humans crave closure, definitive answers. We want our origin stories neat and comprehensible. Yet the universe offers us something else, an endless unfolding of questions, each answer revealing new mysteries, deeper paradoxes. But there's profound beauty in this uncertainty. Consider that your consciousness, this remarkable phenomenon allowing you to contemplate the cosmos, arises from the very matter forged in stellar furnaces. The carbon in your cells, the iron in your blood, the calcium in your bones. These elements were not present at the supposed beginning. They were synthesized in the hearts of dying stars, scattered across space in magnificent supernovae explosions, eventually coalescing into planets, into life, into you. You are, quite literally, made of stardust. Not metaphorically, not poetically, but atomically. Your very existence is proof that the universe has evolved, transformed, complexified over billions of years. You are a way for the cosmos to know itself, to contemplate its own mysteries. And those mysteries run deeper than you might imagine. Even our understanding of the stuff of the universe is undergoing radical revision. The matter we can see and touch, the stars, planets, galaxies, dust, and gas, represents less than 5% of the cosmos. The rest consists of dark matter and dark energy, invisible entities we can detect only through their gravitational effects. Dark matter acts as a cosmic scaffolding, its gravity holding galaxies together when they should fly apart based on their visible mass alone. Dark energy works in opposition, accelerating the universe's expansion, pushing galaxies away from each other at an ever-increasing rate. Together, these invisible components comprise 95% of our universe. We live in a cosmos largely composed of substances we cannot directly detect, whose fundamental nature remains profoundly mysterious. What does this mean for our creation story? If we don't fully understand what the universe is made of now, how can we claim to understand its origins? We're like children finding the last few pages of an epic novel and trying to deduce the entire plot. We might get some elements right, but the full story almost certainly eludes us. Let's return to that mental image of rewinding the cosmic film reel. As we approach what conventional cosmology calls the beginning, we enter a realm where quantum effects dominate. In this quantum realm, causality itself becomes blurred. Effects need not follow causes in the orderly fashion we're accustomed to. Time may branch or loop or behave in ways that defy our macroscopic intuitions. Quantum mechanics, our best theory for describing reality at the smallest scales, suggests that particles can exist in multiple states simultaneously, until observed. They can appear to communicate instantaneously across vast distances, seemingly violating the cosmic speed limit set by light. They can tunnel through energy barriers that should be impenetrable according to classical physics. Now imagine these. Quantum weirdness is magnified to cosmic scales in the extremely dense, hot conditions of the early universe. Space and time themselves become subject to quantum uncertainty. The clean, linear narrative of cosmic evolution dissolves into a probability cloud of possible histories. According to one interpretation of quantum cosmology, the universe may not have had a single, definite beginning, but rather exists as a superposition of possible beginnings. Just as a particle can be in multiple places simultaneously until measured, the universe itself might encompass multiple origin stories, multiple trajectories of evolution, all somehow coexisting in a higher dimensional reality we cannot directly perceive. If this seems incomprehensible, you're in good company. Richard Feynman, one of the greatest physicists of the 20th century, famously remarked, "If you think you understand quantum mechanics, you don't understand quantum mechanics." When applied to cosmology, quantum theory becomes even more mind-bending, challenging not just our understanding of the world, but our understanding of understanding itself. Yet despite these profound uncertainties, cosmologists haven't abandoned the quest to comprehend our origins. New theoretical frameworks continue to emerge, each offering a different perspective on the beginning, or the eternal existence of everything. One particularly provocative idea suggests that our universe might be a simulation, a sophisticated computer program run by some advanced civilization. In this scenario, the Big Bang wouldn't be a physical event, but rather the moment when the cosmic simulation was initiated. The laws of physics would be lines of code, fundamental constants, mere parameters set by the programmers. While this might sound like science fiction, philosophers and physicists take the simulation hypothesis surprisingly seriously. After all, if consciousness can arise from physical processes in the brain, essentially information processing, then couldn't similar consciousness arise in a sufficiently complex simulation? And if we accept that possibility, how can we be certain we're not living in such a simulation ourselves? But even the simulation hypothesis doesn't truly resolve the question of beginnings. It merely pushes it back a level. What about the universe in which the simulators exist? Did that have a beginning? We find ourselves in an infinite regression, each answer spawning new questions. Perhaps we're approaching the question all wrong. Maybe, "How did the universe begin?" is like asking, "What does the color blue smell like?" A category error that meshes concepts in ways that don't meaningfully connect. Perhaps existence itself is simply the default state, and non-existence is the true mystery. Why is there something rather than nothing? Maybe because nothing isn't actually an option. Maybe existence, in some form, is necessary. This brings us to another possibility. What if our universe emerged from a vacuum fluctuation, a quantum hiccup in a pre-existing state of nothingness? Quantum field theory suggests that even a perfect vacuum isn't truly empty, but seethes with virtual particles, constantly popping in and out of existence. In very rare circumstances, these fluctuations might give rise to an entire universe. Imagine the cosmos as an ocean, with our universe just one bubble rising from its depths. This bubble expands, developing complex structures, eventually harboring conscious beings who look back and wonder where it all came from. But the bubble didn't come from nowhere. It emerged from the quantum possibilities inherent in the cosmic ocean itself. This quantum cosmology suggests something profound. Creation requires no creator, no initial push, no divine intervention. The mathematical laws that govern quantum mechanics might themselves necessitate the existence of universes. In this view, our universe isn't a miraculous exception to nothingness, but an inevitable manifestation of underlying quantum reality. Yet, again, we find ourselves pushing the question back rather than answering it. Where did this quantum vacuum come from? What established the laws that govern quantum fluctuations? We seem caught in an endless series of turtles, each standing on the back of another. Perhaps the most honest response to the question of cosmic origins is profound humility. We are biological creatures evolved to survive on the African savanna, using minds developed to track prey and avoid predators, not to comprehend quantum gravity or multidimensional realities. That we've come as far as we have in understanding the cosmos is arguably more surprising than our persistent confusion about the deepest questions. But this humility shouldn't be mistaken for defeat. The history of science is one of ever-expanding horizons, of barriers to understanding repeatedly broken through. Phenomena once attributed to gods, lightning, disease, the movements of planets, have yielded to scientific explanation. Perhaps the question of cosmic origins will eventually do the same, or perhaps not. Maybe we're confronting a genuine limit to human comprehension. Maybe there are truths about existence that cannot be expressed in human language or captured by human mathematics. Maybe the beginning of everything, if there was one, lies forever beyond the reach of science. This possibility needn't diminish our pursuit of knowledge. Even if absolute understanding forever eludes us, the journey of discovery remains profoundly worthwhile. Each new insight, each refined theory, brings us closer to the truth, even if we never reach it completely. And what marvelous insights we've already gained. We know that all the matter in your body was forged in stellar explosions billions of years ago. We know that the universe has evolved from a hot, dense state to the vast, cool cosmos we inhabit today. We know that space itself is expanding, carrying galaxies away from each other like raisins in rising bread dough. These discoveries have transformed our understanding of our place in the cosmos. We are not at its center, nor are we separate from it. We are the universe become conscious, matter organized into such exquisite complexity that it can contemplate its own existence. When you ponder the mysteries of the cosmos is pondering itself through you. This perspective offers a kind of cosmic belonging that transcends our uncertainty about beginnings. Whether the universe had a definite starting point or has always existed in some form, you are indisputably part of its ongoing story. Your atoms have existed since nearly the dawn of time, taking different forms, participating in different structures, now temporarily organized into the being reading these words. But this cosmic belonging comes with a profound responsibility. In a universe where conscious beings are rare, at least as far as we currently know, we bear the burden of awareness. We are the eyes through which the cosmos sees itself, the minds through which it contemplates its own existence. If we fail to ask these profound questions, who will? And make no mistake, these questions matter beyond pure intellectual curiosity. Our cosmic origin story shapes how we understand ourselves and our place in the universe. A cosmos with a definite beginning suggests purpose, design, maybe even a designer. An eternal cosmos suggests something else entirely. A reality governed by necessity rather than choice, by physical law rather than conscious intent. These different perspectives have profound implications for how we live our lives, how we structure our societies, how we plan for our collective future. They inform our ethics, our politics, our very sense of what it means to be human in a vast and mysterious universe. Consider this. If the universe began in a Big Bang, emerged from absolute nothingness, This suggests that radical transformation is built into the very fabric of reality. A cosmos that can spring from nothing into something might inspire us to believe in the possibility of profound change, in the emergence of entirely new realities from apparent impossibility. But if the universe has always existed in some form, eternally cycling or transforming, this suggests that change has limits, that patterns repeat, that what seems novel may be part of an ancient rhythm we're only beginning to discern. This perspective might inspire a different kind of wisdom, a recognition of cycles, a humility before eternal processes, a different relationship with time itself. Of course, the truth about cosmic origins won't be determined by which story we find more appealing or useful. Reality exists independent of our preferences. The universe began as it began, or has always existed as it has, regardless of what we believe about it. And yet, belief matters too. The stories we tell about cosmic origins shape how we observe, what questions we ask, which theories we develop. Science does not exist in a philosophical vacuum. It emerges from and contributes to our broader understanding of reality. The boundary between cosmology and philosophy, between describing the universe and interpreting its meaning, has always been permeable. So where does this leave us? Suspended between knowing and not knowing, between the solid ground of observation and the speculative realms of theory, we have mapped the cosmic microwave background radiation, the oldest light in the universe, dating back to about 380,000 years after the supposed beginning. We have developed mathematical models that can describe cosmic evolution with remarkable precision from that point forward. But the first fraction of a second, the time between the supposed beginning and the earliest state we can confidently describe, remains shrouded in mystery. Different theories offer different accounts, and we lack the observational evidence to definitively choose between them. This is the humbling reality of cosmic inquiry. The further back we look, the less certain our knowledge becomes. We are archaeologists of time, piecing together fragments, developing narratives that fit the evidence while remaining open to revision as new discoveries emerge, and new discoveries will emerge. Gravitational wave astronomy, barely a decade old, has already opened a new window onto the cosmos, allowing us to detect the ripples in space-time caused by colliding black holes and neutron stars. Future technologies may allow us to detect primordial gravitational waves from the earliest moments after the Big Bang, providing crucial evidence for or against various origin theories. Powerful new telescopes, both Earth-based and in space, will peer ever further into cosmic history, revealing galaxies at earlier stages of formation, helping us refine our models of cosmic evolution. Particle accelerators may reach energies that replicate conditions closer to the supposed beginning, testing theoretical predictions about how matter behaves under extreme conditions. But for now, we live with uncertainty, not as a temporary state to be overcome, but as an essential condition of cosmic inquiry. The truth about what lies beyond everything we can currently observe remains elusive, a horizon that recedes as we approach it. This uncertainty need not be a source of frustration. It can be an invitation to wonder, to continued exploration, to intellectual humility. The cosmos is vaster and stranger than we can fully comprehend, and there's a kind of liberation in acknowledging this. We need not have all the answers to appreciate the magnificence of the questions. Look up at the night sky. Those stars, those distant galaxies, exist in a universe that may have no beginning, or whose beginning may be utterly unlike anything we've yet imagined. The light reaching your eyes has traveled across vast cosmic distances, carrying information about a past we're still struggling to understand. In that moment of looking up, you participate in something profound. The universe, through you, contemplates its own origins. Whatever the truth about cosmic beginnings, this capacity for wonder, for questioning, for seeking understanding, this is a kind of magic woven into the fabric of existence. That consciousness has emerged from stardust. That matter has organized itself into beings that question matter's origins. This is perhaps the greatest mystery of all. So we continue to ask, to observe, to theorize. We trace cosmic evolution, backward as far as our instruments and mathematics allow. We develop new conceptual frameworks to make sense of what we find. And perhaps, someday, we'll develop a theory of everything that encompasses the beginning or the eternal existence of the cosmos, or perhaps not. Perhaps some questions will always exceed our grasp, not because they have no answers, but because the answers exist in a realm beyond human comprehension. Perhaps the truth about cosmic origins is not something that can be known, but only approached asymptotically, each new theory bringing us closer without ever reaching complete understanding. Either way, the journey continues. Each generation builds upon the insights of the last, refining our cosmic story, adding details, revising misconceptions. And you're part of this journey, not just as an observer, but as a participant. The questions you ask, the curiosity you bring, the wonder you feel when contemplating the cosmos, these are not separate from the cosmic story, but integral to its unfolding. For in a universe that may have no beginning, that may exist in a state of eternal becoming, the present moment is not merely a consequence of the past, but a generative nexus, a pivot point from which new possibilities emerge. Your consciousness, your questioning, your search for understanding. These are not footnotes to cosmic history, but active ingredients in the universe's ongoing evolution. So as we venture deeper into cosmic mysteries, as we question our most fundamental assumptions about the nature of reality and the origins of everything, remember this: the quest itself has value. The wondering matters. The journey toward understanding, however incomplete, is part of what gives meaning to our brief lives in this vast and ancient, or perhaps eternal, cosmos. The universe may never have begun, but our quest to understand it continues. Each question leading to new questions, each answer provisional, each insight a stepping stone toward deeper comprehension. In this endless inquiry, we find not certainty, but something perhaps more valuable. A humble, awe-filled relationship with a reality larger than we can fully grasp, but which we can endlessly explore. And perhaps that's enough. Not answers, but worthy questions. Not certainty, but the courage to live meaningfully within uncertainty. Not a complete cosmic story, but the privilege of contributing to its ongoing composition. In a universe that may have no beginning, our quest for understanding has no end. And there's a strange comfort in that continuity, a belonging that transcends our cosmic confusion. So what lies beyond everything? Perhaps it's not a what, but a how. Not a static reality waiting to be discovered, but a dynamic process of becoming that we're already part of. Perhaps the truth about cosmic origins isn't something to find, but something to participate in. Each question, each theory, each moment of wonder, adding another thread to the cosmic tapestry. In that spirit, let us continue our journey into cosmic mysteries, not expecting final answers, but committed to asking ever better questions. For in a universe that may have had no beginning, that may exist in eternal transformation, the question itself becomes a form of answer. Not an endpoint, but a portal. Not a conclusion, but an opening into ever deeper wonder. Imagine standing on the shore of an infinite ocean at night. The water stretches beyond the horizon, beyond what your eyes can perceive, beyond what your mind can grasp. Each wave that crashes against the sand carries whispers from distant realms, cosmic messages encoded in the rhythm of water and foam. This ocean is our universe, and those whispers are the echoes of its most fundamental laws. For centuries, we've struggled to decode these whispers. We've developed increasingly sophisticated instruments, telescopes, particle accelerators, gravitational wave detectors, each revealing another layer of cosmic reality. Yet for every answer we uncover, new questions emerge like shadows lengthening at dusk. The universe reveals itself reluctantly, in fragments and riddles, never offering the complete picture we so desperately seek. Let's begin with what we think we know, the standard model of cosmology that forms the backbone of our current understanding. According to this model, approximately 13.8 billion years ago, all matter, energy, space, and time erupted from a singularity, a point of infinite density and temperature. From this initial explosion, the universe expanded and cooled, allowing fundamental particles to form, then atoms, then stars and galaxies, and eventually, on at least one pale blue dot circling an ordinary star, life complex enough to wonder about its own origins. This narrative, the Big Bang Theory, has served as our cosmic origin story for nearly a century. It's elegant, supported by substantial observational evidence, and allows us to trace cosmic evolution from a fraction of a second after the supposed beginning to the present day with remarkable precision. The discovery of the cosmic microwave background radiation, the afterglow of the Big Bang, offered compelling evidence that the universe did indeed evolve from a hot, dense state. But here's where certainty begins to fray like a rope stretched to its breaking point. While the Big Bang Theory elegantly explains the universe's evolution from a hot, dense state to its current form, it struggles to explain how that initial state came to be. The mathematics of general relativity, our best theory of gravity, breaks down as we approach the singularity. Physical laws, as we understand them, cease to function meaningfully. This isn't merely a gap in our knowledge, it's a tear in the fabric of understanding itself. When we say the laws of physics break down at the singularity, we're not just acknowledging a temporary limitation in our theories. We're confronting the possibility that reality itself functions in ways fundamentally unlike anything we've yet conceived. Consider the early universe, not as it's typically portrayed in simplistic documentaries, but as modern physics actually describes it. In the first infinitesimal fraction of a second after the supposed beginning, the universe wasn't just hot. It was a churning cauldron where space and time themselves were malleable, where the four fundamental forces we now recognize were unified in ways we can barely mathematically model, let alone visualize. Physicists call this earliest period the Planck era, the first 10^43 seconds after the supposed beginning. During this unimaginably brief moment, quantum effects dominated gravity in ways our current theories cannot adequately describe. We lack a unified theory of quantum gravity that could explain the behavior of reality under such extreme conditions. Try to envision this primordial state, not as a small, dense point in pre-existing space, but as a reality where space itself was compressed to quantum scales, where time flowed differently, or perhaps didn't flow at all in any way we would recognize. In this quantum foam of space-time, causality as we understand it may not have applied. Effects might precede causes. Multiple histories might exist simultaneously. The arrow of time might point in multiple directions at once. Now pause here and let this sink in. Our entire conception of cosmic evolution depends on extrapolating backward from current conditions. It's like trying to determine the source of a river by following its flow upstream. But what if the river doesn't have a traditional source? What if, instead of emerging from a single spring, it materializes from underground aquifers, from rainfall, from countless tributary streams too small to name? What if its beginning isn't a point, but a process? The Big Bang Theory doesn't actually describe the bang itself. It describes what happened afterward. It's like having a detailed account of a tree's growth while remaining completely ignorant of the seed from which it sprouted. We've charted the universe's expansion and cooling with remarkable precision. But the singular moment of creation, if such a moment existed, remains shrouded in mystery. And here's where the first major contradiction emerges. If the universe began from a singularity, a point of infinite density, then it represents a breakdown in the laws of physics as we understand them. Yet we use these same laws to extrapolate backward and infer the singularity's existence. We're using tools that we acknowledge fail under the very conditions we're trying to investigate. It's like trying to measure the ocean's depth with a ruler that dissolves in water. This isn't just a technical problem awaiting a clever solution. It's a fundamental paradox that suggests our entire conceptual framework might be inadequate. What if the apparent singularity isn't a real feature of cosmic history, but an artifact of our mathematical models? An indication that we're approaching the problem with the wrong tools, the wrong concepts, the wrong questions. Some theoretical physicists suggest that the singularity predicted by general relativity may be avoided when quantum effects are properly accounted for. In quantum mechanics, true infinities rarely occur in physical systems. Instead, we find minimum units, fundamental limits, like the Planck length, the smallest meaningful distance in quantum theory, or the Planck time, the smallest meaningful duration. Imagine the early universe not as an infinitesimal point, but as a quantum object existing at the Planck scale, roughly 10 to the 35 meters, a distance so small that to compare it to an atom would be like comparing an atom to the entire observable universe. At this scale, space may not be continuous, but granular, composed of indivisible units like pixels on a digital screen. Time, too, might come in discrete packages rather than flowing smoothly. In this quantum realm, the deterministic laws of classical physics give way to probability and uncertainty. Particles can exist in multiple states simultaneously. Empty space teems with virtual particles popping in and out of existence. Distant objects can be quantum entangled, sharing information instantaneously across vast distances in ways that seem to violate the cosmic speed limit set by light. Now scale these quantum weirdnesses up to cosmic proportions. What if the early universe existed as a quantum superposition of multiple possible states? What if, instead of a single definite history, the cosmos encompassed many potential histories simultaneously, each with its own physical laws, its own evolutionary trajectory, its own possibility space? This isn't mere speculation, it's a serious proposal in quantum cosmology. According to this view, our universe might be just one realized possibility among many, selected through a process analogous to quantum measurement. The apparent singularity at the beginning wouldn't be a physical event, but rather a boundary condition, a starting assumption in our model rather than a feature of reality itself. But even quantum cosmology, with all its mind-bending implications, may not resolve the fundamental question: why is there something rather than nothing? Why does the universe, with its galaxies and stars, its physical laws and mathematical regularities, its capacity to evolve complex structures, including conscious beings, exist at all? This question haunts the boundaries between physics and philosophy. Science can tell us how the universe evolved, how complex structures emerged from simpler components, how the conditions necessary for life arose on at least one planet. But the question of why there is existence at all seems to transcend the scientific method as currently practiced. Some physicists argue that this why question is meaningless, that existence is simply the default state, and non-existence is a logical impossibility. Others suggest that our universe emerged spontaneously from the quantum vacuum, a free lunch permitted by the strange bookkeeping of quantum field theory, where particles and antiparticles can appear from nothing as long as they sum to zero. Still, others propose that our universe is part of a vast multiverse, a cosmic landscape of bubble universes, each with its own physical laws, its own dimensional structure, its own evolutionary history. In this scenario, our universe isn't special or chosen. It's just one of countless cosmic experiments, distinguished only by the fact that it happens to have physical parameters conducive to the evolution of conscious observers. This last possibility, the multiverse hypothesis, introduces another profound paradox. If there are infinite universes with varying physical laws, then every possible configuration of matter and energy must exist somewhere. In some universes, the laws of physics might be so different that conscious life as we understand it couldn't evolve. In others, conditions might closely resemble our own cosmos, but with subtle variations. The multiverse hypothesis transforms cosmic fine-tuning from a mystery requiring explanation into a statistical inevitability. Of course, we find ourselves in a universe whose fundamental constants allow for complex structures. We couldn't exist in one that didn't. This is the anthropic principle. The universe appears finely tuned for life because if it weren't, we wouldn't be here to observe it. But this explanation comes at a cost. If our universe is just one bubble in an infinite cosmic foam, then most of reality lies forever beyond our observational reach. We're confined to our bubble, our observable universe, our light cone. The vast majority of existence, if the multiverse hypothesis is correct, is inaccessible to us in principle, not just in practice. This is a profoundly humbling perspective. Not only are we not at the center of the universe, but our entire universe might be just one unremarkable region in a cosmos too vast to comprehend. Worse still, most of that cosmos might be permanently beyond our ability to observe or influence. We're like microorganisms living in a droplet of water, unaware of the ocean in which our droplet floats. Yet even this humbling perspective doesn't resolve the ultimate question. If our universe is part of a multiverse, what created the multiverse? If quantum fluctuations can produce entire universes, what established the quantum fields from which these fluctuations arise? We seem caught in an infinite regress, each answer spawning new questions like a cosmic version of a child's persistent why. Perhaps we're trying to apply concepts of causality and origin where they don't meaningfully apply. Our minds evolved to understand middle-world phenomena, objects roughly our size moving at speeds we can perceive over timescales relevant to our survival. We instinctively think in terms of causes and effects, beginnings and endings, objects with clear boundaries, moving through pre-existing space. But the cosmos, as revealed by modern physics, defies these intuitions at every turn. At the quantum level, causality blurs. At cosmic scales, space itself expands. At relativistic speeds, time dilates. Near black holes, space and time switch roles. Reality is far stranger than our evolved intuitions prepared us to comprehend. Consider space itself, not the objects within it, but the very fabric of space-time. We tend to think of space as a container, a pre-existing arena in which cosmic events unfold. But according to general relativity, Space is dynamic, responsive, alive with activity. It curves in the presence of mass and energy. It ripples with gravitational waves. It expands as the universe evolves. When we say the universe is expanding, we don't mean it's getting bigger within some larger container. There is no container. There is no outside to the universe. Space itself is stretching, carrying galaxies along like raisins in rising bread dough. The distance between galaxies increases not because they're moving through static space, but because space itself is expanding between them. This expansion has profound implications for our understanding of cosmic structure. If space has been expanding since the supposed beginning, then winding the cosmic clock backward doesn't lead to all matter converging at a single point in pre-existing space. Rather, it suggests that the entire observable universe was once compressed into a volume smaller than a proton, with space itself compressed along with everything in it. But here we encounter another paradox. If the universe is expanding, what is it expanding into? Our intuition demands an answer. Some larger arena, some cosmic container. But cosmology suggests there is no into. The expansion is intrinsic to space itself. It's not expanding into anything. It's just expanding. Imagine drawing dots on the surface of a balloon and then inflating it. The dots move away from each other as the balloon expands, but they're not moving into some pre-existing space. They're moving because the surface itself is stretching. Now, imagine this happening in all three dimensions simultaneously. That's closer to how cosmic expansion works. But if the universe isn't expanding into anything, then what lies beyond its edge? Another paradox. According to our best models, the universe has no edge. It might be infinite, extending forever in all directions. Or it might be finite but unbounded, like the surface of a sphere. You could travel forever without reaching an edge, eventually returning to your starting point. Either way, there's no outside to the universe, no boundary beyond which some other reality exists. This defies our intuitive understanding of objects and containers. We're accustomed to thinking of things as being bounded, as having insides and outsides. But the universe as a whole may defy this categorization. Now consider time, not as the steady tick of seconds on a clock, but as a dimension interwoven with space in the fabric of reality. According to relativity, time isn't absolute, but relative to the observer's frame of reference. It flows differently depending on gravity and velocity. Near a black hole, time slows dramatically. At speeds approaching light, time dilates. These aren't just mathematical abstractions, they're experimentally verified facts. Atomic clocks on airplanes run slightly faster than identical clocks on the ground. GPS satellites must account for relativistic time dilation to maintain accuracy. Time, like space, is malleable, responsive to conditions, variable rather than fixed. If time itself is relative rather than absolute, what does this mean for the concept of a cosmic beginning? Did time begin with the Big Bang, or did the Big Bang occur within some pre-existing temporal framework? If time began with the Big Bang, then asking what came before is meaningless. There was no before in which anything could happen. But if time didn't begin with the Big Bang, if our universe emerged within some larger temporal context, then we're back to the infinite regress of causes. What caused that larger temporal framework to exist? When did it begin? We chase the beginning ever backward, never reaching a satisfactory answer. Perhaps time itself is more complex than our linear conception suggests. Some physicists propose that time might branch like a tree, with each quantum decision creating a new timeline. Others suggest it might be circular or cyclic, with the end of one cosmic epoch feeding into the beginning of another. Still others argue that time as we experience it is emergent, not a fundamental feature of reality, but a macroscopic phenomenon arising from more basic quantum processes. All of these possibilities challenge our conventional understanding of beginnings and endings. If time branches, then the beginning might be just one node in a vast temporal network. If time is cyclic, then there is no absolute beginning, just an eternal cycle of cosmic death and rebirth. If time is emergent, then at the most fundamental level, the concept of beginning might not even apply. Let's pivot now to the concept of infinity, both in space and time. Our minds recoil from true infinity. We can define it mathematically, manipulate it in equations, but we cannot truly visualize or intuitively grasp what infinite really means. Yet, cosmology suggests that the universe might indeed be spatially infinite, extending forever in all directions. If space is infinite, then everything that can happen within the laws of physics must happen somewhere, and not just once, but an infinite number of times. In an infinite universe, there must be infinitely many planets identical to Earth, populated by beings identical to you, reading identical words on identical screens. There must also be planets almost identical to Earth, where history unfolded slightly differently, where you made different choices, lived different lives, became different versions of yourself. This isn't mysticism or science fiction. It's a logical consequence of infinite space containing finite arrangements of matter. With infinite cosmic real estate, but only a finite number of ways to arrange particles within any given region, patterns must eventually repeat. You must exist, again and again and again, scattered across the infinite cosmic landscape. But infinity creates problems for cosmology. If the universe is infinitely old as well as infinitely large, then why isn't it in a state of maximum entropy, a uniform, featureless soup where no complex structures can exist? According to thermodynamics, closed systems naturally evolve toward states of higher entropy, greater disorder. An infinitely old universe should have reached maximum entropy infinite time ago. Yet we observe a universe full of structure. Galaxies, stars, planets, living systems, all representing states of relatively low entropy, high organization. This suggests that either the universe isn't infinitely old, or it isn't a closed system. Either it had a beginning, or it's somehow receiving an entropy subsidy from somewhere beyond itself. These considerations lead us back to the most fundamental cosmological questions. Is the universe finite or infinite? Did it have a beginning, or has it always existed in some form? Is it unique, or is it one of many in a vast multiverse? Our best current data suggests that the observable universe, the portion from which light has had time to reach us since the Big Bang, is finite. In size, roughly 93 billion light-years in diameter. But the observable universe is just the part we can see. The actual universe might extend far beyond this observational horizon, possibly to infinity. As for cosmic age, the evidence strongly indicates that our universe evolved from a hot, dense state about 13.8 billion years ago. But whether this represents an absolute beginning or merely a transition from some previous state remains an open question. Different theories offer different perspectives, and we lack decisive observational evidence to choose between them. One particularly elegant theory proposes that our universe is the result of quantum tunneling from a pre-existing universe. In quantum mechanics, particles can sometimes pass through energy barriers that would be insurmountable according to classical physics, a phenomenon called quantum tunneling. Perhaps our entire universe quantum tunneled into existence from a parent universe, inheriting some characteristics while developing others independently. This scenario would be like a bubble forming within another bubble, connected by a quantum channel too subtle for us to detect with current technology. Our universe would have a beginning from our perspective, the moment of tunneling, but would exist within a larger cosmic context that might be eternal. Other theories propose more exotic connections between our universe and what lies beyond. Some suggest that black holes in our universe might give birth to new universes, with each black hole singularity spawning a new cosmic bubble with its own space, time, and physical laws. In this scenario, universes reproduce almost biologically, with black holes serving as cosmic wombs. This would mean that somewhere in the cosmic past, our universe emerged from a black hole in a parent universe, and the black holes in our universe are currently gestating daughter universes, continuing the cosmic reproductive cycle. Universe reproduction would be subject to a kind of natural selection, with universes that produce many black holes leaving more cosmic offspring than those that produce few. Such scenarios blur the line between cosmology and biology, suggesting that universes might evolve through processes analogous to biological evolution. Universes well suited to black hole production would proliferate, while those poorly suited would leave few or no cosmic descendants. Over time, the multiverse would become dominated by universes fertile in black hole production. Remarkably, the physical parameters that optimize black hole production also seem conducive to the evolution of life. Stars must live long enough to forge heavy elements but eventually die to scatter these elements through space. Gravity must be strong enough to form galaxies and stars, but not so strong that all matter rapidly collapses into black holes. Chemistry must be complex enough to allow for information-rich molecules like DNA. This correlation between conditions favorable for life and conditions favorable for black hole production has led some theorists to propose that the apparent fine-tuning of our universe for life might actually be fine-tuning for black hole production. Life could be a cosmic side effect, an unintended consequence of physical laws optimized for an entirely different purpose. But these speculations, fascinating as they are, remain just that, speculations. We cannot directly observe other universes or what lies beyond our cosmic horizon. We cannot perform experiments to test these theories in the traditional scientific sense. We're limited to mathematical consistency, theoretical elegance, and indirect observational constraints. This places cosmic origin theories in an unusual epistemological category. Not quite traditional science, not quite pure philosophy, but a hybrid approach that uses mathematical models to explore possibilities beyond direct observation. We might call it speculative physics or theoretical cosmology, acknowledging both its scientific rigor and its speculative nature. The boundary between what we know and what we speculate becomes increasingly blurry as we approach the limits of observation. We know with high confidence that the universe is expanding because we can directly measure this expansion through galactic redshifts. We know with reasonable confidence that this expansion is accelerating because multiple independent lines of evidence point to this conclusion. But as we extrapolate backward toward the supposed beginning or forward toward the ultimate fate of the cosmos, our confidence necessarily decreases. The further we move from direct observation, the more we depend on theoretical models whose assumptions might not hold under extreme conditions. This doesn't mean that speculative cosmology is worthless or unscientific. Science has always operated at the boundary between the known and the unknown, using established principles to explore new territories. Many ideas now considered foundational, atomic theory, relativity, quantum mechanics, began as speculative leaps beyond the observational evidence of their time. What it does mean is that we should hold our cosmic origin stories lightly, recognizing them as provisional narratives subject to revision as new evidence emerges and new theoretical frameworks develop. The history of cosmology is littered with abandoned models, from the steady-state theory to various inflation scenarios that failed to match observational data. The current standard model, with its Big Bang, cosmic inflation, dark matter, and dark energy, represents our best current understanding, but it contains acknowledged gaps and puzzles, particularly regarding cosmic origins and the nature of dark components. Future observations may fill these gaps within the current framework, or they may force a revolutionary reconceptualization of cosmic reality. One area where such a revolution might occur involves dark energy, the mysterious force accelerating cosmic expansion. Discovered in the late 1990s through observations of distant supernovae, dark energy accounts for approximately 68% of the total energy content of the observable universe. Yet we know almost nothing about its fundamental nature. The simplest explanation for dark energy is that it represents the energy of empty space itself, a cosmological constant as originally proposed by Einstein. But when physicists attempt to calculate the expected value of this constant using quantum field theory, they get a result that's off by a factor of 10. 120, perhaps the most dramatic disagreement between theoretical prediction and observation in the history of science. This discrepancy suggests that we're missing something fundamental about the relationship between quantum physics and gravity, between the very small and the very large. Whatever dark energy is, it's not behaving according to our current theoretical frameworks. It's as if the universe is expanding into an invisible cosmic medium that exerts negative pressure, pushing galaxies apart rather than pulling them together. Dark energy raises profound questions about cosmic destiny. If it remains constant as space expands, then the universe will continue expanding forever, eventually becoming a cold, diffuse, largely featureless void. Galaxies beyond our local group will accelerate away from us, eventually moving faster than light relative to our position. This doesn't violate relativity because it's space itself expanding, not objects moving through static space. In this scenario, the Big Freeze, or heat death, the observable universe slowly empties as galaxies disappear beyond our cosmic horizon. Stars burn out. Black holes gradually evaporate through Hawking radiation. Atoms decay. Eventually, even protons might disintegrate, leaving nothing but dispersed elementary particles separated by literally astronomical distances. But if dark energy isn't constant, if it strengthens over time, then a more dramatic fate awaits. In the Big Rip scenario, accelerating expansion eventually becomes so violent that it tears apart galaxies, stars, planets, atoms, and ultimately subatomic particles. Space expands so rapidly that no stable structures can exist. The universe ends not with a whimper, but with a cosmic shredding of reality itself. Alternatively, if dark energy weakens or reverses sign, cosmic expansion could halt and reverse, leading to a big crunch where all matter reconverges in a fiery implosion. This could be the end of our universe, or it could be a transition to a new cosmic cycle, with the crunch serving as the bang for a subsequent expansion. The universe might breathe in cycles, expanding, contracting, expanding again, perhaps eternally. These scenarios, freeze, rip, crunch, bounce, represent different cosmic destinies depending on the nature of dark energy and other factors. But they all share a common feature. What began must end or transform. If the universe had a beginning, it will have an ending of some kind, even if that ending gives birth to a new beginning. This cyclic possibility brings us back to the question of beginnings. If the universe cycles through periods of expansion and contraction, did this cycling itself have a beginning? Or has the cosmic respiration continued eternally, with no first breath, no ultimate origin? Some cyclic models suggest that each cycle increases entropy slightly, meaning that the cycles cannot continue indefinitely into the past. Others propose mechanisms for entropy reset at the bounce, potentially allowing for eternal cycling. Mathematics becomes increasingly speculative as we pursue these questions, pushing beyond what current observational evidence can constrain. But perhaps the most profound insight from modern cosmology isn't about beginnings or endings at all. It's about the present moment and our place within cosmic evolution. Regardless of how the universe began or how it will end, we find ourselves at a remarkable juncture in cosmic history. We exist roughly 13.8 billion years after the apparent beginning, far enough from the initial chaos for complex structures to form, but not so far that star formation has ceased. We orbit a stable main-sequence star with enough heavy elements to form rocky planets. We inhabit a galaxy neither too active with supernova explosions nor too quiescent to forge new elements. In cosmic terms, we live in a habitable epoch just as we live in a habitable zone around our star. Had we emerged much earlier, the universe would have been too hot and volatile for complex life. Had we emerged much later, after star formation ceased, we would have missed the cosmic window for biological evolution. This temporal fitness complements spatial fitness, our position in a galactic habitable zone, not too close to the dangerous galactic center, nor too far in the metal-poor outer reaches. We inhabit a planetary sweet spot, not too close to our star, nor too distant, allowing for liquid water and complex chemistry. These nested habitable zones, cosmic, galactic, stellar, planetary, suggest either remarkable coincidence or some underlying principle favoring the emergence of observers. The anthropic principle offers one explanation. Observers can only arise in regions of the multiverse compatible with their existence, so, of course, we find ourselves in such a region. But this anthropic reasoning, while logically sound, leaves many unsatisfied. It explains why we observe a life-compatible universe, but doesn't explain why such a universe exists among the possibilities. It transforms the question from "Why is the universe bio-friendly?" to "Why does the multiverse include?" Bio-friendly regions? The mystery shifts, but doesn't dissolve. Another perspective sees conscious observation as an emergent cosmic function rather than an accidental byproduct. In this view, consciousness represents the universe's capacity to observe itself, to transform implicit information into explicit knowledge. We are how the cosmos comes to know itself, not the purpose of cosmic evolution, perhaps, but a natural consequence of its complexity-generating tendencies. This perspective aligns with certain interpretations of quantum mechanics, particularly those that emphasize the role of observation in collapsing quantum superpositions into definite states. If observation plays a fundamental role in actualizing potential realities, then perhaps consciousness isn't accidental but integral to cosmic functioning. Such ideas verge on the philosophical, even the spiritual. They suggest a universe that's not merely a collection of material objects interacting according to blind forces, but an integrated system evolving toward greater complexity, self-organization, and self-awareness. Not designed or guided in a traditional religious sense, but inherently generative of meaning and purpose. Of course, we must be careful not to project human concepts like purpose and meaning onto cosmic processes. The universe doesn't have goals, in the human sense. It doesn't strive or desire or plan. It evolves according to physical laws that we can partially describe, but not fully explain. The emergence of complexity, life, and consciousness may be natural consequences of these laws rather than their purpose. Yet the boundary between description and explanation, between how and why, becomes increasingly blurry as we approach fundamental questions. Why do physical laws exist at all? Why do they take the forms they do? Why does the universe exhibit mathematical regularity rather than chaotic unpredictability? These questions lie at the intersection of physics, philosophy, and mathematics. They challenge not just our scientific models, but our very conception of what constitutes an explanation. Is it enough to describe how the universe behaves, or must we also account for why it behaves that way, rather than some other way? Some physicists argue that these why questions are meaningless, that the universe simply is what it is, and physical laws are descriptions rather than explanations. Others suggest that a complete theory of everything would explain not just how the universe works, but why it must work that way, why no other physical laws could consistently exist. String theory represents one attempt at such a comprehensive explanation. It proposes that all fundamental particles are actually tiny vibrating strings, their different vibration patterns giving rise to different particle properties. These strings exist not in the familiar 3 dimensions of space plus 1 of time, but in a higher dimensional reality, with additional dimensions curled up so tightly that we cannot directly perceive them. In some versions of string theory, the particular way these extra dimensions are compactified determines the physical laws in our 4-dimensional space-time. Different compactifications yield different physics, different particles, different forces, different cosmological constants. The mathematical constraints are so tight that perhaps only one configuration or a small set of configurations are logically possible. If true, this would transform the apparent arbitrariness of physical laws into a kind of mathematical necessity. The universe would be as it is because it couldn't logically be otherwise. The fine-tuning for life wouldn't require a multiverse explanation or a designer. It would emerge naturally from the mathematical structure of reality itself. But string theory remains speculative, mathematically elegant but lacking definitive, experimental confirmation. It represents one possibility among many in the landscape of theories seeking to unify quantum mechanics and gravity, to provide a complete account of physical reality from the smallest scales to the largest. Other approaches, like loop quantum gravity, causal set theory, and causal dynamical triangulations, offer alternative paths toward the same goal. Each provides a different perspective on fundamental questions, a different conceptual framework for understanding space, time, and the origins of everything. What unites these diverse theoretical approaches is a recognition that our current understanding is incomplete. The standard model of particle physics works brilliantly within its domain, as does general relativity within its domain. But these domains don't fully overlap, and in the regions where they should, like black hole interiors or the very early universe, our theories break down. This incompleteness isn't a failure of science, but a stimulus for further exploration, an acknowledgement that our cosmic journey of discovery continues. Each generation builds upon the insights of the last, refining models, developing new conceptual frameworks, pushing observational technology to new limits. And what remarkable limits we've reached! We've detected gravitational waves from colliding black holes over 1 billion light-years away. We've imaged the shadow cast by the supermassive black hole at the center of a distant galaxy. We've mapped the cosmic microwave background radiation with astonishing precision, revealing the seeds of cosmic structure when the universe was just 380,000 years old. These achievements represent not just technological triumphs, but conceptual ones, the ability to test ideas that once seemed permanently beyond empirical reach. They remind us that the boundary between the observable and the unobservable isn't fixed, but expands with our ingenuity and perseverance. Yet despite these remarkable achievements, the deepest questions about cosmic origins remain incompletely answered. We've pushed our understanding further back in time, closer to the supposed beginning, but we haven't reached it, and perhaps we never will in the traditional scientific sense. This doesn't mean we should abandon the quest or resign ourselves to permanent ignorance. It means we should hold multiple possibilities in mind simultaneously, recognizing that our cosmic origin story is still being written, still evolving as new evidence emerges and new theoretical frameworks develop. The universe might have begun in a Big Bang, or it might be eternally cycling, or it might have quantum-tunneled from a parent universe, or it might be a simulation running in a higher reality. It might be unique, or it might be one of countless universes in a vast multiverse. Its physical laws might be arbitrary, or they might be mathematically necessary, or they might have evolved through a kind of cosmic natural selection. Each of these possibilities has its advocates among serious scientists, each its theoretical advantages and challenges, each its philosophical and existential implications. Together, they remind us that our understanding of cosmic origins remains provisional, a work in progress rather than a completed narrative. This provisionality needn't be disappointing. On the contrary, it's exhilarating to live at a time when such profound questions remain open, when multiple compelling possibilities compete for acceptance, when new observational evidence continues to refine our understanding of cosmic history. We are cosmic detectives piecing together clues from light that has traveled billions of years across expanding space, from particles created in high-energy collisions, from the whispers of gravitational waves rippling through the fabric of space-time. Each clue adds to our understanding. Each observation constrains the range of possible theories. Each breakthrough technology opens new windows onto cosmic reality. And while the ultimate origin of everything might remain beyond our complete comprehension, at least within current scientific frameworks, the quest itself has value. It stretches our minds, challenges our preconceptions, connects us to a reality larger than ourselves, and places our brief human story within the grandest context imaginable, the evolution of the cosmos itself. In that cosmic context, we are both insignificant and extraordinary. Insignificant in our physical size and temporal duration, extraordinary in our capacity to comprehend the universe that gave us birth. We are the mechanism through which the cosmos comes to know itself, to reflect on its own existence, to wonder about its own origins. This capacity for wonder, this drive to understand, even when complete understanding might elude us, is perhaps our most distinctly human quality. It connects us to something beyond ourselves, beyond our species, beyond our planet, beyond our time. It places us within a lineage of cosmic explorers stretching back to the first humans who looked up at the night sky and wondered what those points of light might be. So as we continue our exploration of cosmic mysteries, as we push against the boundaries of current understanding, let's embrace both the knowledge we've gained and the questions that remain. Let's recognize that the story of cosmic origins isn't finished. It's still unfolding, still revealing itself, still surprising us with unexpected twists and turns. And perhaps that's as it should be. A cosmos complex enough to generate stars, and planets, life and consciousness, mathematics and music deserves an origin story equally rich in mystery and meaning, equally resistant to simplistic explanation, equally worthy of our deepest wonder and most rigorous investigation. So let us continue to ask, to observe, to theorize, to imagine. Let us hold multiple possibilities in mind simultaneously, recognizing that the truth about cosmic origins, if there is a singular truth, may be stranger and more wonderful than anything we've yet conceived. Let us approach these profound questions with both scientific rigor and philosophical openness, both skeptical inquiry and awestruck wonder. The stars are lying to you. Not intentionally, of course. Stars have no agency, no capacity for deception. But the light that reaches your eyes from those distant suns has traveled across incomprehensible distances, through dust clouds and gravitational fields, bending and stretching along the way. What you perceive as a singular point of light might be a binary star system, a distant galaxy, or even a star that exploded thousands of years ago, its final message only now reaching your retina. Our entire perception of the cosmos is filtered through the limitations of light, that ancient, ghostly messenger traversing the void at 299,792 to 458 meters per second. Fast by human standards, yet agonizingly slow on the cosmic scale. When you gaze at Andromeda, our nearest galactic neighbor, you're seeing it as it existed 2.5 million years ago. If an advanced civilization there were looking back at us right now, they wouldn't see humans. They'd see early hominids just beginning to use stone tools. This delay, this cosmic lag, is the first of many veils separating us from ultimate reality. We're perpetually looking at a delayed broadcast of the universe, never experiencing cosmic events in real time. And this simple fact, that light takes time to travel, opens the door to one of the most profound paradoxes in modern cosmology, the horizon problem. Imagine the universe as a vast ocean, and you're standing on a tiny island in its midst. Your horizon, the furthest distance you can see, is limited by the curvature of the Earth. Similarly, our cosmic horizon is limited by the distance light has been able to travel since the beginning of the universe. Regions of space beyond this horizon have never been able to communicate with us, their light still en route after nearly 14 billion years. Here's the paradox. When we look at the cosmic microwave background radiation, the afterglow of the Big Bang, we find it's remarkably uniform. Regions of space that could never have communicated with each other somehow reached the same temperature, to within 1 part in 100,000. It's as if two people on opposite sides of the Earth, who have never met or spoken, independently wrote identical novels, word for word. How could regions of space that never exchanged information have reached such perfect equilibrium? This question plagued cosmologists until the early 1980s, when Alan Guth proposed a revolutionary solution: cosmic inflation. According to this theory, the early universe underwent a phase of exponential expansion, doubling in size every 10 pro 35 seconds. A region of space smaller than a proton expanded to cosmic scales in a fraction of a second, smoothing out temperature differences before they could form. Inflation elegantly solves the horizon problem. Before inflation, the observable universe was a microscopic, causally connected region. After inflation, these formerly connected regions were scattered across what would become our cosmic horizon. The uniformity we observe isn't coincidental. It's the remnant of an ancient connection, preserved like a fossil in cosmic radiation. But inflation raises as many questions as it answers. What triggered this explosive expansion? What caused it to stop? And most crucially, what came before it? To address these questions, we must venture beyond conventional physics into a realm where space and time behave in ways that defy our macroscopic intuitions. We must delve into quantum gravity, the still theoretical merger of quantum mechanics and general relativity that might explain how reality behaves at the smallest scales and highest energies. Imagine reality as a film reel, where time is not flowing, but where every moment already exists. Each frame on this cosmic film contains a complete snapshot of the universe at a particular instant. From our perspective within the film, we experience these frames sequentially, creating the illusion of flowing time. But from outside the real, if such a perspective could exist, all moments would appear equally real, equally present. This view of time, known as eternalism or the block universe, emerges naturally from Einstein's theories of relativity. According to relativity, there is no universal now. Different observers will disagree about which events are happening simultaneously, depending on their relative motion. This suggests that all moments, past, present, and future, exist on equal ontological footing. The passage of time might be a persistent illusion rather than a fundamental feature of reality. If all moments exist eternally, then what do we make of the apparent beginning of time at the Big Bang? Perhaps it's not truly a beginning, but merely an edge of our cosmic film reel. The first frame in our particular sequence, but not necessarily the first frame of a larger reality. This brings us to one of the most profound questions in cosmology. Did time itself begin with the Big Bang? Or did the Big Bang occur within some pre-existing temporal framework? Conventional Big Bang cosmology suggests that time itself began approximately 13.8 billion years ago. There was no before the Big Bang in this model because time didn't exist yet. Asking what came before the Big Bang would be like asking what's north of the North Pole. The question contains a category error. But quantum gravity offers alternative perspectives. In loop quantum cosmology, a branch of loop quantum gravity, the Big Bang is replaced by a big bounce, a cosmic contraction, followed by an expansion. Time extends before our Big Bang, through a previous universe that collapsed and rebounded to form our current one. The mathematics of this scenario are complex, involving the quantization of space-time itself. Imagine space not as a continuous fabric, but as a network of discrete nodes, like a chain-link fence rather than a smooth sheet. At extremely small scales, the Planck scale of approximately 10⁻35 meters, space becomes granular, composed of indivisible units like pixels on Susan, a digital screen. In this quantized perspective, the apparent singularity at the Big Bang dissolves. Instead of space and time shrinking to an infinitesimal point of infinite density, they reach a minimum size determined by quantum mechanics. The universe contracts until it reaches this minimum, then bounces back into expansion. If the Big Bounce model is correct, our universe might be just one phase in an eternal cycle of expansion and contraction. The Big Bang wasn't the beginning of everything, but merely the beginning of our current cosmic epoch, a transition point rather than a true origin. Other models propose even more exotic possibilities. String theory, our leading candidate for a theory of quantum gravity, suggests that our universe might be one of many branes, short for membranes, floating in a higher dimensional space. Our entire four-dimensional reality could be embedded within a larger reality, possessing additional spatial dimensions. In certain versions of this brane cosmology, our Big Bang resulted from a collision between two such branes. Imagine two gigantic sheets floating in a higher dimensional space, gradually approaching each other until they collide. The energy of this collision manifests in our four-dimensional perspective as a sudden burst of energy and expansion, what we interpret as the Big Bang. This scenario doesn't just push the beginning back one step. It fundamentally reconceptualizes what the beginning means. Our universe didn't emerge from nothing but from a pre-existing higher dimensional reality with its own physics, its own history, its own conception of time. But how could we possibly test such theories? The energies involved in these processes are far beyond what we can create in particle accelerators. The scales involved are smaller than we can directly observe. The events occurred billions of years ago, leaving only subtle traces in the cosmic distribution of matter and energy. This is where observational cosmology becomes crucial. While we can't directly observe the beginning, we can detect its echoes in the present-day universe. The cosmic microwave background radiation, the distribution of galaxies, the abundance of light elements like hydrogen and helium, all these provide clues about the early universe and constrain our theoretical models. For instance, the precise pattern of temperature fluctuations in the cosmic microwave background matches what inflation theories predict. The observed ratio of hydrogen to helium aligns with calculations from Big Bang nucleosynthesis models. The large-scale structure of the universe, the cosmic web of galaxies, clusters, and voids, bears the imprint of quantum fluctuations from the earliest moments after the Big Bang. These observations don't definitively prove any single model of cosmic origins, but they narrow the field of possibilities. They establish boundary conditions that any viable theory must satisfy. They transform abstract mathematical conjectures into empirically testable hypotheses. Yet even with these constraints, multiple models remain viable. The Big Bang followed by inflation remains the standard framework, but variations of the Big Bounce, brain cosmology, and other exotic scenarios haven't been conclusively ruled out. The beginning, if there was one, remains shrouded in theoretical ambiguity. This ambiguity extends to the ultimate fate of the universe as well. Will cosmic expansion continue forever, leading to a big freeze where galaxies drift apart, stars burn out, and even atoms eventually decay? Will dark energy strengthen over time, accelerating expansion until it tears apart the fabric of reality? In a big rip, will expansion eventually reverse, leading to a big crunch that might seed another cycle of cosmic evolution? The answer depends largely on the nature of dark energy, the mysterious force accelerating cosmic expansion. Current observations suggest that dark energy behaves approximately like Einstein's cosmological constant, maintaining constant density as space expands. If this holds true, expansion will continue forever, albeit at a gradually decreasing rate. But dark energy might not be constant. It might strengthen over time, or weaken, or even reverse sign. Our observations cover only a brief cosmic moment, the last few billion years in a nearly 14 billion-year history. Extrapolating from this limited dataset to eternity involves significant uncertainty. Moreover, quantum effects might alter the long-term evolution of the universe in ways we can't yet predict. According to quantum field theory, empty space isn't truly empty, but seethes with virtual particles popping in and out of existence. These quantum fluctuations might influence cosmic evolution over sufficiently long timescales, potentially triggering phase transitions that fundamentally alter physical laws. Some physicists speculate that our universe might exist in a false vacuum state, a temporarily stable configuration that could decay into a lower energy state. This decay would propagate outward at the speed of light, effectively rewriting physical laws in its wake. From within our region of space, we would have no warning before this wave of cosmic restructuring reached us. These speculations might seem abstract, far removed from human concerns, but they reflect a profound truth. The universe is dynamic, evolving, full of hidden potentials and constrained by physical laws we only partially understand. The cosmos we observe today is just a snapshot of a continuous process of becoming, with a past we can partly reconstruct and a future we can only dimly forecast. This perspective, seeing the universe as a process rather than a static entity, is central to modern cosmology. The cosmos isn't a fixed arena in which events unfold. It's an evolving system shaped by its own internal dynamics. Space expands. Galaxies form and collide. Stars burn and die. Black holes evaporate. Even the vacuum itself might be unstable, pregnant with unrealized possibilities. And this brings us to one of the most provocative questions in contemporary physics. Is our universe unique, or is it one among many in a vast multiverse? The multiverse hypothesis comes in several variations, each emerging from different theoretical frameworks. The inflationary multiverse suggests that cosmic inflation didn't end everywhere simultaneously. Some regions stopped inflating and formed bubble universes like ours, while inflation continued elsewhere, generating new bubbles with potentially different physical laws. Imagine cosmic inflation as a vast, expanding sea of unrealized potential. Within this sea, bubbles form where inflation ceases. Each bubble evolves according to its own internal dynamics, potentially developing its own physical laws, its own structural patterns, its own possibility space for complexity and life. Our universe would be just one such bubble in an endless, cosmic foam. Another version of the multiverse emerges from string theory, which suggests that elementary particles are actually tiny vibrating strings, whose different vibration patterns correspond to different particle properties. These strings exist in a higher dimensional space, with additional dimensions curled up so tightly that we can't directly perceive them. The mathematics of string theory permits an enormous number of ways these extra dimensions can be configured. Roughly 500 different possibilities, each yielding a universe with different physical laws. This landscape of possible universes is so vast that it dwarfs our capacity to fully explore it, even mathematically. If string theory is correct, and if each mathematically permissible configuration actually exists in some region of the multiverse, then our universe is just one possibility among an effectively infinite set. Its physical laws aren't unique or inevitable, but represent one draw from a cosmic lottery of possibilities. A third version of the multiverse emerges from quantum mechanics, specifically from the many worlds interpretation proposed by Hugh Everett in the 1950s. According to this interpretation, quantum events don't have single, definite outcomes. Instead, reality branches at each quantum decision point, creating new universes for each possible outcome. Imagine dropping a quantum particle onto a screen with two slits. In conventional quantum mechanics, the particle passes through both slits, simultaneously in a state of superposition, then collapses to a definite position when observed. In the many worlds interpretation, the universe splits when the particle reaches the slits. In one universe, it goes through the left slit. In another, it goes through the right. No collapse occurs. Reality itself branches to accommodate all possibilities. If the many worlds interpretation is correct, then our universe is constantly splitting into countless variations, each representing a different outcome of quantum events. The universe where you decide to scratch your nose exists alongside the universe where you decide not to. The universe where a particular radioactive atom decays now exists alongside the universe where it decays a moment later. These different multiverse concepts aren't mutually exclusive. Our reality might include inflationary bubbles with different physical laws, each experiencing quantum branching at every moment. The full multiverse would be a nested structure of extraordinary complexity. Universes within universes within universes, branching and evolving according to their internal physics. But is the multiverse a scientific concept, or is it metaphysical? Speculation beyond empirical testing? Critics argue that since we can't observe other universes, the multiverse represents a departure from scientific methodology. Proponents counter that the multiverse isn't an ad hoc addition to our theories, but emerges naturally from well-established physical frameworks like inflation, string theory, and quantum mechanics. Moreover, certain versions of the multiverse might leave detectable signatures in our observable universe. If our universe collided with another bubble universe in the distant past, this might leave patterns in the cosmic microwave background radiation. If quantum branching occurs as the many worlds interpretation suggests, this might manifest in subtle ways in quantum experiments. The multiverse also offers a potential explanation for cosmic fine-tuning, the observation that numerous physical parameters seem exquisitely tuned to permit the evolution of complex structures, including life. The strength of fundamental forces, the masses of elementary particles, the dark energy density, if any of these differed slightly from their observed values, stars couldn't form, chemistry would be impossible, or the universe would have recollapsed. Before life could evolve, this fine-tuning presents a puzzle. Why do physical constants have the precise values necessary for complexity and life? Is this a cosmic coincidence, evidence of design, or something else entirely? The multiverse offers a statistical explanation. If countless universes exist with different physical laws, then of course we find ourselves in one compatible with our existence. This isn't mysterious. It's a selection effect. We can only observe universes capable of producing observers. The multiverse transforms cosmic fine-tuning from a puzzle requiring explanation into a statistical inevitability. But the multiverse isn't the only possible explanation for fine-tuning. Some theorists propose that a complete unified theory of physics might actually predict the values of fundamental constants, showing that they couldn't be otherwise. What appears to be fine-tuning might actually be mathematical necessity, the only self-consistent configuration possible. Others suggest that physical constants might be dynamic rather than fixed, evolving over cosmic time through processes analogous to natural selection. Universes that produce numerous black holes, for instance, might reproduce by spawning new universes through each black hole, passing on their physical parameters with slight mutations. Over cosmic generations, universes would evolve toward parameter values conducive to black hole production, which, perhaps not coincidentally, also seem conducive to life. These different perspectives on cosmic fine-tuning reflect broader philosophical tensions in modern physics. Is the universe ultimately comprehensible through pure mathematics, its structure determined by necessity rather than chance? Or is there an irreducible element of contingency, of things that could have been otherwise, that shapes cosmic reality? This question connects to ancient philosophical debates about necessity versus contingency, determinism versus chance, mechanism versus teleology. Modern physics hasn't resolved these debates, but has transformed them, expressing age-old philosophical puzzles in the precise language of mathematics and empirical observation. Even the concept of physical law itself becomes problematic at the EU. Boundaries of modern physics. Are physical laws descriptive or prescriptive? Do they govern reality, or do they merely describe consistent patterns in natural phenomena? Are they themselves subject to evolution over cosmic time, or are they eternal and unchanging? String theory suggests that what we perceive as physical laws are consequences of the specific way extra dimensions are configured in our region of the multiverse. Change the configuration, and different laws emerge. This perspective transforms physics from the discovery of universal laws to the exploration of how particular configurations yield particular dynamical patterns. Loop quantum gravity suggests that space-time itself is emergent, arising from more fundamental quantum processes operating at the Planck scale. In this view, general relativity, our best description of gravity, isn't a fundamental law but an E/D approximation that works well at macroscopic scales. The true laws operate at a deeper level, generating space and time as emergent phenomena. These theories point to a profound possibility. What we call fundamental physics might not be truly fundamental. There might be deeper layers of reality generating what we perceive as space, time, and physical law. Our current theories, impressive as they are, might be effective descriptions rather than ultimate truths, approximations valid within limited domains rather than complete accounts of reality. This perspective hints at what philosophers call the hierarchical structure of reality, the organization of natural phenomena into levels of increasing complexity and emergence. Quantum fields give rise to particles, which form atoms, which combine into molecules, which constitute cells, which aggregate into organisms, which form societies. Each level has its own patterns, regularities, and organizing principles. Physics traditionally seeks the bottom level of this hierarchy, the most fundamental constituents and laws from which everything else emerges. But what if there is no bottom level? What if reality is infinitely layered, with each apparent foundation revealing new depths upon closer examination? Some philosophers and physicists have proposed that reality might be fundamentally mathematical, that mathematical structures don't just describe the universe, but actually constitute it. In this view, known as mathematical Platonism or the mathematical universe hypothesis, physical reality is isomorphic to a mathematical structure. The universe doesn't merely follow mathematical laws, it is a mathematical object. This perspective transforms the puzzle of why mathematics describes reality so effectively. Mathematics works because reality is mathematical. The abstract patterns we discover through mathematical reasoning aren't human inventions but features of fundamental reality, accessed through our evolved capacity for logical thought. But this raises another question. Why this mathematical structure, and not another? Why these physical laws, these constants, these dimensions? Even if reality is fundamentally mathematical, the particular mathematics instantiated in our universe seems contingent rather than necessary, unless, perhaps, it isn't. Some theorists propose that all mathematically consistent structures exist as universes in the multiverse. In this view, physical reality encompasses all logically possible patterns, all consistent mathematical structures. Some of these structures would be simple, others complex. Some would permit the evolution of conscious observers, others wouldn't. This mathematical multiverse represents the ultimate extrapolation of cosmic plurality. Not just many universes, but all possible universes existing as mathematical entities. It transforms the question, why does the universe exist? Into why does mathematics exist? Shifting from physics to metaphysics, from empirical science to fundamental ontology. These speculations might seem remote from practical physics, but they emerge naturally from attempts to understand quantum gravity, cosmic origins, and the nature of physical law. They reflect the integration of theoretical physics with philosophy, mathematics, and cosmology, disciplines converging at the boundaries of current knowledge. And this convergence brings us back to the question of beginnings. If the multiverse exists in any of its theorized forms, did it have a beginning? Or is it eternal, with bubbles continually forming, universes constantly branching, a perpetual process without origin or end? Some versions of the multiverse appear compatible with eternal existence. Inflationary models suggest that while bubble universes like ours might have beginnings, the inflationary process itself could be eternal, continuously generating new bubbles without any definite starting point. The many worlds interpretation similarly suggests a continuous branching without clear origin. Each quantum event creates new branches, but the quantum wave function itself might be eternal, encompassing all possible configurations without beginning or end. Even our own universe might lack a true beginning if it emerged from a pre-existing multiverse. whether through inflation, brain collision, quantum tunneling, or some other transition. The Big Bang would mark the beginning of our cosmic domain, but not the beginning of everything. Yet eternal existence creates its own puzzles. If the multiverse has existed forever, why isn't it in a state of thermal equilibrium, a uniform soup, of maximum entropy? Why does structure exist at all? Why aren't all possibilities already exhausted, all stories already told, all patterns already explored? One response involves the concept of eternal inflation, where the multiverse continuously expands faster than entropy can equilibrate across it. New regions emerge faster than old regions decay, maintaining pockets of order and complexity indefinitely. The multiverse outpaces entropy, staying eternally young even as its individual regions age and decay. Another possibility involves quantum fluctuations from a pre-existing state of minimum entropy. According to quantum field theory, even the most ordered state experiences fluctuations, temporary deviations from perfect symmetry or equilibrium. Perhaps our universe began as such a fluctuation, a random deviation that expanded to cosmic scales. But quantum fluctuations typically return to equilibrium. What caused this particular fluctuation to expand rather than recollapse? What set the initial conditions that determined its evolutionary trajectory? Each answer spawns new questions. Each explanation requires further explanation, in a potentially infinite regress of causes. This regress connects to philosophical puzzles about ultimate explanations. Is there a self-explanatory ground of being that requires no further justification? Or does explanation continue indefinitely, with each layer revealing new questions? Can we ever reach a point where we can say, "This is why everything exists," and require no further explanation? Some philosophers and physicists propose that mathematical necessity might provide this ultimate ground. If reality is fundamentally mathematical, and if the particular mathematics of our universe or multiverse is the only self-consistent possibility, then its existence would be logically necessary rather than contingent or caused. Others suggest that existence itself might be the default state, with non-existence representing a logical impossibility rather than a foregone possibility. In this view, the puzzle isn't why something exists rather than nothing, but why we ever thought nothing was a coherent alternative. Still, others propose that these questions themselves might be misconceived, products of human cognitive limitations rather than features of fundamental reality. Perhaps the concepts of cause, beginning, and explanation are themselves emergent approximations useful at human scales, but inapplicable to ultimate reality. This perspective connects to the ancient philosophical insight that our categories of understanding might not capture reality as it is in itself. We perceive and conceptualize the world through evolved cognitive faculties adapted for navigating middle-world phenomena. Objects roughly our size, moving at moderate speeds over human timescales. When we apply these faculties to quantum phenomena, cosmic scales, or ultimate origins, we might be stretching our conceptual apparatus beyond its range of validity. Yet we have no choice but to use the cognitive tools available to us. We can extend these tools through mathematics, technology, and careful reasoning, but we cannot escape our embodied, evolved perspective entirely. The questions we ask about cosmic origins and the answers we find satisfying are inevitably shaped by our cognitive architecture, our evolutionary history, our cultural context. This doesn't mean these questions are meaningless or that progress is impossible, but it does suggest a kind of epistemic humility, a recognition that our understanding of cosmic origins, however sophisticated, remains provisional, approximative, and shaped by perspectival limitations. With this humility in mind, let's turn to one of the most profound mysteries in modern physics, The nature of time itself. Is time a fundamental feature of reality, or is it emergent from deeper processes? Does it flow in one direction only, or could it loop, branch, or reverse? Did it begin with the Big Bang, or is it eternal? According to general relativity, time is interwoven with space in a four-dimensional continuum called space-time. This continuum can stretch, compress, and curve in response to mass and energy. Near massive objects like black holes, time slows down relative to regions farther away. At speeds approaching light, time dilates, passing more slowly for moving observers than for stationary ones. These effects aren't mere theoretical predictions. They're experimentally verified facts. Atomic clocks on airplanes run slightly faster than identical clocks on the ground. GPS satellites must account for both special and general relativistic time dilation to maintain accuracy. Time, as revealed by modern physics, is relative rather than absolute. But relativity also suggests something even more profound. There is no universal now across the cosmos. Events that appear simultaneous to one observer may appear sequential to another, depending on their relative motion. The present moment isn't a cosmic feature, but a perspective-dependent construct. This relativistic view of time challenges our intuitive sense of a universal flow from past to future. If simultaneity is relative, then the distinction between past, present, and future becomes blurry. Events don't inherently possess the quality of being past or future. These designations depend on the observer's reference frame. Some philosophers and physicists interpret this to mean that all moments in time, past, present, and future, exist equally in a four-dimensional block. Universe. The flow of time would be a psychological phenomenon rather than a fundamental feature of reality. All moments would be equally real, equally present in the cosmic film reel, with our consciousness creating the illusion of temporal flow as it moves from frame to frame. Quantum mechanics complicates this picture further. According to the standard interpretation, quantum systems exist in superpositions of multiple states until measured, at which point they collapse to a definite value. This measurement process appears to introduce an irreversible arrow of time, a I/D distinction between before and after measurement that isn't present in the underlying equations. Wheeler and Feynman developed a model of electromagnetism in which electromagnetic waves travel both forward and backward in time, with these bidirectional effects precisely canceling to create the apparent one-way flow we observe. Their work hints at a deeper symmetry in physical laws, with time's arrow emerging from boundary conditions rather than fundamental asymmetry. Similar ideas appear in quantum cosmology, particularly in the no-boundary proposal developed by Stephen Hawking and James Hartley. According to this model, asking about the beginning of time is like asking about the edge of the Earth. Just as the Earth's surface has no boundary despite being finite, time might have no beginning despite having finite extent into the past. In the no-boundary proposal, the early universe is described by a wave function that includes all possible histories, with no single history having a definite beginning. Time as we understand it would emerge only as the universe expanded, and classical physics became a good approximation. Before that, in the quantum gravity regime, the concept of time as a one-dimensional parameter flowing from past to future wouldn't apply. These models suggest a profound possibility. Time as we experience it, with a definite past, an uncertain future, and a flowing present, might be an emergent phenomenon rather than a fundamental feature of reality. The true nature of temporal reality might be radically different from our intuitive understanding. Some theorists propose that time might be discrete rather than continuous, composed of indivisible units like pixels on a screen. Others suggest it might be two-dimensional or higher-dimensional, with what we perceive as a one-way flow actually representing movement through a more complex temporal manifold. Loop quantum gravity suggests that time might emerge from more fundamental quantum processes operating at the Planck scale. In this view, temporal flow would be a macroscopic approximation, similar to how temperature emerges from the collective behavior of atoms, even though individual atoms don't have a temperature. These perspectives challenge the very idea of a cosmic beginning. If time isn't fundamental but emergent, then asking about the beginning of time might be conceptually confused, like asking about the temperature of a single atom or the wetness of a single water molecule. The concept might simply not apply at the level where we're trying to use it. This brings us to one of the most speculative but fascinating areas of theoretical physics: the possibility that our universe might be a simulation created by an advanced civilization. First popularized by philosopher Nick Bostrom, the simulation hypothesis suggests that what we perceive as physical reality might actually be a sophisticated computer program running on substrate beyond our direct perception. While this might sound like science fiction, philosophers and physicists take the idea surprisingly seriously. If consciousness can arise from physical processes in the brain, essentially information processing, then couldn't similar consciousness arise in a sufficiently complex simulation? And if we accept that possibility, how can we be certain we're not living in such a simulation ourselves? The simulation hypothesis connects to religious and philosophical traditions, suggesting that perceived reality might be illusory or constructed. But unlike traditional idealism or subjective solipsism, the simulation hypothesis proposes a specific mechanism for this construction: computation performed by entities existing in a base reality beyond our own. If we are living in a simulation, what might this imply about cosmic origins? The Big Bang wouldn't represent the beginning of everything, but merely the initiation of our particular simulation. Time, space, and physical law would be parameters in the program, rather than fundamental features of ultimate reality. This perspective doesn't solve the puzzle of ultimate origins. It merely pushes it back a level. What about the universe in which the simulators exist? Did that have a beginning? We find ourselves in the same infinite regress of causes, with each explanation requiring further explanation. Unless, perhaps, the simulation is recursive, a nested structure where simulated beings create their own simulations, which create further simulations in an endless chain of virtual realities. Each level would perceive those above it as more real and those below it as less real. But the distinction might be meaningless from a sufficiently detached perspective. This nested simulation model connects to certain interpretations of quantum mechanics, particularly those involving observer-dependent reality. If observation plays a fundamental role in collapsing quantum possibilities into definite outcomes, then perhaps consciousness isn't epiphenomenal but integral to reality's functioning, the mechanism through which potential becomes actual. Some theorists propose that consciousness itself might be fundamental rather than emergent, a basic feature of reality like space, time, or matter. In this view, known as panpsychism or pan-experientialism, consciousness doesn't arise from physical complexity, but is inherent in all physical systems to some degree, becoming more complex and self-reflective in certain organized structures like brains. If consciousness is fundamental, and if it plays a role in actualizing potential realities, then the puzzle of cosmic origins takes on new dimensions. The universe wouldn't be merely a collection of particles evolving according to fixed laws, but a participatory reality shaped by the awareness within it. Observation wouldn't merely reveal pre-existing facts, but would participate in determining which potential facts become actual. This perspective resonates with Wheeler's concept of the participatory universe, where observer and observed form an inseparable whole. It suggests that reality isn't out there independent of perception, but constituted through the interaction of consciousness with possibility space. Such ideas verge on the mystical, but they emerge from serious engagement. With quantum measurement problems, consciousness studies, and information theory, they represent attempts to integrate the observer, previously excluded from physical theory as an unnecessary complication, into a comprehensive account of reality. These diverse perspectives on cosmic origins, from inflation and quantum bounces to brains and simulations, reflect the creative ferment of contemporary theoretical physics. Multiple models compete to explain the same phenomena, each with its strengths and weaknesses, each capturing some aspect of reality while missing others. This theoretical diversity isn't a failure of physics, but a sign of its vitality. We're not converging on a single, definitive answer about cosmic origins, but exploring a landscape of possibilities, mapping the conceptual terrain, identifying constraints and connections between different approaches. The quest for ultimate origins continues, guided by mathematical consistency, empirical constraints, and philosophical reflection. Each theory reveals something about the cosmos or about our own conceptual frameworks. Each perspective illuminates some aspect of reality while leaving others in shadow. Perhaps the truth about cosmic origins isn't singular but plural, not one definitive narrative but a tapestry of interwoven stories, each capturing an aspect of a reality too complex for any single conceptual framework to fully encompass. Or perhaps there is a unified theory waiting to be discovered, a comprehensive framework that seamlessly integrates quantum mechanics and gravity, explains cosmic origins and evolution, accounts for consciousness and observation, and resolves the puzzles of time, causality, and existence itself. This hypothetical theory of everything represents the holy grail of theoretical physics, a complete mathematical description of all physical phenomena from the smallest scales to the largest, from the earliest moments to the distant future. String theory currently stands as the leading candidate for such a unified framework. By representing elementary particles as tiny vibrating strings, it potentially unifies the four fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force within a single mathematical structure. But string theory remains incomplete, with multiple formulations and no definitive experimental confirmation. It requires additional spatial dimensions beyond the familiar three, dimensions curled up so tightly that we cannot directly perceive them. It generates a vast landscape of possible physical laws rather than uniquely predicting the constants. We observe. Loop quantum gravity offers an alternative approach, directly quantizing space-time itself rather than starting from particle interactions. It suggests that space is granular at the Planck scale, composed of indivisible units with quantum properties. This framework elegantly explains how general relativity emerges at macroscopic scales while avoiding singularities at extreme densities. But loop quantum gravity struggles to incorporate the other fundamental forces in a natural way. It remains primarily a theory of quantum gravity rather than a complete unification of all physical forces. Other approaches, causal set theory, asymptotic safety, causal dynamical triangulations, and more, offer additional perspectives, each capturing some aspect of quantum gravity while missing others. The proliferation of theories reflects both the mathematical richness of the problem and the scarcity of experimental guidance at the relevant energy scales. This theoretical diversity presents both challenge and opportunity. It challenges us to develop new experimental tests, new mathematical tools, new conceptual frameworks to distinguish between competing models. It offers the opportunity to explore different perspectives, to identify common patterns across diverse approaches, to develop a more nuanced understanding of reality's structure. The search for a theory of everything connects to deeper philosophical questions about scientific explanation, reductionism, emergence, and the limits of human understanding. Is reality ultimately reducible to a single mathematical framework? Or is it irreducibly plural, with different levels requiring different explanatory approaches? Can human minds fully comprehend the fundamental structure of reality, or are we cognitively limited in ways that preclude complete understanding? You have spent your entire life believing in tomorrow. Every night, you close your eyes with the unspoken certainty that the sun will rise again, that time will continue its relentless march forward, that the universe will persist in its ancient, unfathomable dance. This faith, this unexamined assumption, underlies every decision you make, every plan you craft, every dream you nurture. But what if this most fundamental belief is nothing more than a comforting illusion? Take a moment. Feel the weight of your body against the surface supporting you. Notice your breath, that automatic rhythm of existence. Observe your thoughts arising and dissolving like waves on a cosmic shore. All of this feels undeniably real, undeniably present. But is it? The theories we've explored suggest something profoundly disturbing. That what you experience as now, this singular, precious moment of conscious awareness, may be just one point in a vast tapestry that already exists in its entirety. If time is an illusion, then everything you've ever done, and everything you will ever do, might already exist, unchangeable and eternal. Like words in a book that has already been written. Your future joys, your coming sorrows, your eventual death, all may already be there, fixed points in a four-dimensional structure that only seems to flow because of how your consciousness moves through it. Your sense of agency, of making choices that shape your destiny, might be as illusory as the apparent motion of pages in a flipbook. This isn't mere philosophical speculation. It emerges directly from Einstein's relativity, our most successful theory of space and time. According to relativity, there is no universal now stretching across the cosmos. Events that appear simultaneous to one observer may appear sequential to another. The distinction between past, present, and future dissolves into a matter of perspective, a question of where you stand in the cosmic landscape rather than an objective feature of reality. If all moments exist equally, if your birth, your death, and all instants between coexist in a timeless block universe, then what becomes of meaning? What happens to hope, to ambition, to the human quest for betterment? If the cosmic film already contains its ending, why do we feel the desperate need to keep turning the pages of our stories? Perhaps even more unsettling is the possibility raised by certain quantum cosmologies that your life isn't just playing out once in this frozen temporal landscape, but is repeating infinitely, throughout an eternal multiverse. In an infinite cosmos, everything that can happen must happen. Not just once, but an infinite number of times. Somewhere, a version of you is reading these exact words right now. Somewhere else, a version of you decided against it. In another region of the multiverse, you were never born. In yet another, human life never evolved. And in countless others, identical copies of you are living identical lives, thinking identical thoughts, experiencing identical emotions, destined for identical fates. If quantum immortality theorists are correct, then your conscious experience might continue indefinitely through this branching structure of reality. Each time your death becomes imminent in one branch, your consciousness would follow only those paths where you survive, creating the subjective impression of impossible luck or miraculous escapes. You would never experience your own non-existence, only the infinite extension of experience through increasingly improbable scenarios. But this immortality would come at a terrible price. As the branches where you survive become increasingly rare and unusual, you would find yourself increasingly isolated in strange realities, outliving loved ones, surviving catastrophes, persisting in increasingly damaged or diminished states. Quantum immortality would not be a blessing, but a cosmic horror, an inescapable persistence through ever-deteriorating circumstances. Now zoom out further. The Earth, this pale blue dot that contains all human history, all our struggles and triumphs, all our art and science and love and war, is an infinitesimal speck orbiting an ordinary star in an ordinary galaxy among hundreds of billions of galaxies. Our entire observable universe might be just one bubble in an infinite cosmic foam, one branch in an endlessly bifurcating quantum tree, one simulation among countless others run by entities we cannot comprehend. Scale alone renders human concerns vanishingly insignificant. If you could somehow perceive the universe in its true vastness, in its true complexity, in its true age, your mind would shatter like glass. We evolved to comprehend threats and opportunities on the savannah, to navigate social hierarchies in small tribes, to plan for seasons and years, not to grasp billions of light years or billions of years, not to conceptualize higher dimensions or quantum superpositions. When Lovecraft wrote of cosmic horror, of entities so vast and alien that merely perceiving them drives humans mad, he was touching on a psychological truth. Our minds cannot truly comprehend the scales and strangeness revealed by modern cosmology. We use mathematics as a crutch, we develop analogies and visualizations, but we cannot truly internalize what these theories imply about the nature of reality and our place within it. Consider the concept of infinity, not as a mathematical abstraction, but as a lived reality. In an infinite universe, everything that can happen does happen. Every possibility, no matter how vanishingly improbable, occurs an infinite number of times. Every triumph, every atrocity, every joy, every suffering, all repeating endlessly across the cosmic landscape. What does individual action mean in such a context? If every possible choice is actualized somewhere, if every possible outcome occurs, then what significance can we attribute to our particular decisions, our particular lives? If every story is told infinite times, what value can any single telling have? Or consider the implications of simulation theory. If we exist within a computed reality, then everything you've ever experienced, your first love, your deepest loss, your most transcendent moment of beauty or connection might be nothing more than algorithmic outputs, bits flipping in a substrate you can never perceive or understand. Your consciousness, your sense of self, your most intimate thoughts might be emergent phenomena in a system designed by entities with motivations you cannot fathom. What if the simulators were to intervene? What if they already have? Those moments of inexplicable synchronicity, those profound coincidences, those inexplicable intuitions, could these be glitches in the program or deliberate manipulations from outside? What if religious experiences, artistic inspiration, scientific breakthroughs are actually interventions from beyond the simulation boundary? Messages from outside seeping through the cracks in our constructed reality? Or what if they simply decide to end the simulation? Everything you know, everything you love, everything you've ever experienced could vanish in an instant. Not through cosmic catastrophe, but through a simple command to terminate the program. Your entire reality could be switched off like a light, with no warning, no recourse, no continuation. Even without invoking simulation, the physical cosmos offers its own existential horrors. The accelerating expansion of the universe, driven by mysterious dark energy, points toward a bleak ultimate fate. Galaxies will drift apart until they're no longer visible from each other. Stars will burn out. Black holes will evaporate. Matter itself may eventually decay. The universe will become an ever colder, ever emptier void. A heat death where no complex structures can exist, no life can persist, no consciousness can observe what remains. This cold, dark, empty fate awaits regardless of what humanity achieves, regardless of how long our species survives, regardless of what wonders we create or atrocities we commit. The cosmic clock is ticking toward absolute zero, toward maximum entropy, toward a state where time itself becomes meaningless because nothing happens, nothing changes, nothing exists to mark its passage. Some physicists propose that even in this heat death, random quantum fluctuations might eventually, after unimaginable eons, generate new structures, new complexity, perhaps even new life. But these would be isolated incidents in an overwhelming void, brief flickers in an eternal darkness. And even these fluctuations would eventually dissipate, leaving the cosmos once again lifeless and still. Or perhaps vacuum decay will claim us first. Current physics suggests our universe might exist in a false vacuum state, temporarily stable but capable of decaying to a lower energy state. This decay would propagate outward at the speed of light, rewriting physical laws in its wake. From our perspective, there would be no warning. A bubble of altered reality could be rushing toward us right now, about to transform our atoms into unrecognizable structures governed by different physical constants. We would never see it coming. We would never feel it happen. Our entire reality would simply end, replaced by something utterly alien that operates according to different rules. Not death as we understand it, not the cessation of consciousness within a continuing world, but the retroactive invalidation of everything we thought was fundamental. Against these cosmic threats, human agency appears laughably inadequate. What defense do we have against vacuum decay? What plan can we implement to avoid the heat death of the universe? What technology could possibly shield us from the fundamental restructuring of physical law? Even more immediate cosmic risks. Asteroid impacts, gamma-ray bursts, nearby supernovae could extinguish human civilization or even all terrestrial life with little or no warning. We exist at the mercy of a universe profoundly indifferent to our survival, our values, our hopes and fears. This cosmic indifference challenges our deepest psychological needs. We evolved to perceive agency in our environment, to seek meaning in our experiences, to believe that our actions matter. The universe revealed by modern cosmology offers no obvious purpose, no clear meaning, no indication that consciousness is anything other than a temporary configuration of matter and energy. Remarkable, perhaps, but ultimately no more cosmically significant than a waterfall or a supernova. What if the universe is alive, and we are just its fleeting thoughts? This panpsychist perspective suggests that consciousness isn't unique to humans or even to biological systems, but is a fundamental feature of reality, present in some form at all levels of organization. In this view, our individual consciousness would be like a wave on a vast ocean of mind, temporarily distinct but ultimately inseparable from the greater whole. If panpsychism is correct, then your conscious experience, your innermost self, isn't confined to your brain, but extends into and merges with the consciousness of everything else. The boundaries you perceive between yourself and the world, between subject and object, would be convenient illusions rather than fundamental divisions. You wouldn't be in the universe. You would be the universe experiencing itself from a particular perspective. This sounds mystical, even comforting, until you consider its implications. If you are the universe experiencing itself, then you are not just the beauty and wonder, but also the suffering and horror. You are the predator and the prey, the oppressor and the victim, the creator and the destroyer. You are complicit in everything because you are everything. There is no escape from cosmic responsibility because there is no boundary between you and what you might wish to escape from. Or perhaps consciousness is even stranger than panpsychism suggests. Some interpretations of quantum mechanics, particularly those involving the measurement problem, suggest that consciousness plays a fundamental role in collapsing quantum possibilities into definite outcomes. If these interpretations are correct, then consciousness isn't just observing reality, it's participating in creating it. This perspective transforms the universe from a pre-existing arena that consciousness observes into a participatory reality that consciousness helps constitute. You wouldn't be merely witnessing cosmic evolution, but actively involved in determining which potential becomes actual, which possibilities materialize into experienced reality. Such a participatory universe would place an overwhelming responsibility on conscious beings. If observation helps determine reality, then how we observe, what we pay attention to, what we value, what we seek to understand, shapes the cosmos in ways we can barely comprehend. Our choices wouldn't just affect our individual lives or even our species, but would ripple outward into the fundamental fabric of reality itself. These possibilities, block universe, multiverse, simulation, panpsychism, participatory reality, aren't mutually exclusive. Reality might incorporate aspects of all these models, creating a cosmic structure even stranger and more complex than any single theory suggests. And this composite reality would be even more resistant to human comprehension, even more challenging to our evolved cognitive frameworks, even more psychologically devastating in its implications. Now, take a breath. Feel the weight of these possibilities. Allow yourself to experience the vertigo of cosmic uncertainty, the existential nausea that comes from questioning your most basic assumptions about reality. This discomfort isn't something to avoid, but to embrace, a necessary stage in developing a more authentic relationship with the cosmos as it actually is, rather than as we wish it to be. Because despite these existential horrors, despite the cosmic indifference, despite the ultimate futility of all human endeavor against the arrow of entropy, something remarkable remains. You are here, now, aware. Whatever the true nature of reality, whatever cosmic processes generated your existence, whatever ultimate fate awaits the universe, you have this moment of consciousness, this brief flicker of awareness in which you can perceive, reflect, wonder. Consciousness itself, whatever its fundamental nature, represents something profound. Through you, the universe has developed the capacity to wonder about itself, to study its own structure, to contemplate its own origins and destiny. Whether consciousness is fundamental or emergent, whether it creates reality or merely observes, its existence is perhaps the most remarkable feature of the cosmos we inhabit. Consider the chain of events that led to your existence. The Big Bang, or whatever more fundamental process it emerged from, the formation of galaxies and stars, the fusion of elements in stellar cores and supernova explosions, the coalescence of our solar system from this stellar debris, the emergence of life on Earth, the evolution of complex organisms, the development of human culture and technology, the specific circumstances that led to your conception and birth, the particular experiences that shaped your neural patterns into the unique configuration that constitutes yourself. Each link in this chain required specific conditions, precise timing, particular arrangements of matter and energy. Change any detail, and you would not exist. The probability of your specific existence, calculated from first principles, would be vanishingly small, effectively zero against the backdrop of cosmic possibilities. Yet here you are. Whatever the true nature of time, whatever the structure of the multiverse, whatever level of reality we inhabit, your consciousness exists. You are having this experience, reading these words, contemplating these ideas. The improbable has occurred. The vanishingly unlikely has manifested. This existence, however brief, however cosmically insignificant, is the fundamental miracle at the heart of your experience. Not a supernatural miracle requiring violation of physical law, but a miracle in the sense of something so improbable, so remarkable, so worthy of awe that it challenges our capacity for wonder. And this miracle extends beyond individual human consciousness. The emergence of life itself, of self-replicating systems capable of evolution, of increasing complexity, of adaptation and response to environmental conditions, represents a cosmic anomaly, a local reversal of the entropy gradient, a temporary but significant deviation from the universe's overall trajectory toward disorder. Life isn't just complex chemistry. It's information processing, environmental sensing, adaptive response. It's matter organized in ways that resist decay, that maintain internal order against the cosmic tide of disorder, that reproduce and evolve and explore the possibility space of existence. Life transforms the dead matter of planets into dynamic, responsive, self-organizing systems that develop increasingly sophisticated ways of persisting against entropy. Consciousness, particularly the self-reflective consciousness characteristic of humans, represents yet another level of cosmic anomaly. Through consciousness, the universe has developed the capacity to model itself, to create internal representations of external reality, to simulate possible futures and reconstruct possible pasts, to develop abstract mathematics and theoretical physics that capture fundamental patterns in cosmic structure. This capacity for modeling reality extends beyond immediate survival needs. Humans contemplate quantum gravity and cosmic inflation, not because this knowledge directly enhances reproductive fitness, but because consciousness naturally seeks to understand, to explore, to grasp the patterns underlying experience. We are reality modeling itself, the cosmos attempting to comprehend its own nature through the temporarily organized matter that constitutes our brains. If consciousness is indeed fundamental rather than emergent, then perhaps this self-modeling capacity isn't unique to humans, but is an intrinsic feature of reality itself. The universe naturally bending back upon itself, creating nested layers of self-reference, developing increasingly sophisticated ways of knowing itself through the complex systems it generates. Either way, whether consciousness emerges from complexity or is fundamental to reality, your awareness represents something profound, a local center of experience in which the universe can contemplate itself, can wonder about its nature, can develop theories and models that capture aspects of its structure and evolution. This capacity for wonder, for reflection, for theoretical modeling, gives rise to another uniquely human experience, the search for meaning. Unlike, as far as we know, any other entity in the cosmos, humans don't merely exist, but question the purpose of their existence. We seek not just survival, but significance, not just persistence, but purpose. This search for meaning collides violently with the cosmic indifference revealed by modern physics. The universe as described by science offers no inherent purpose, no predetermined destiny, no overarching narrative in which human existence plays a predefined role. The cosmos doesn't care whether we live or die, create or destroy, love or hate. It simply is, evolving according to physical laws that operate without regard for human desires or values. And yet, paradoxically, this very indifference creates the space for human meaning-making. In a universe without predetermined purpose, we have the freedom and responsibility to create meaning through our choices, our values, our relationships, our creative acts. Cosmic indifference doesn't negate human meaning, but relocates its source from external cosmic design to internal human valuing. Consider the parallel with cosmic structure. The early universe was remarkably uniform, with matter and energy distributed almost perfectly evenly across space. But within this uniformity, tiny quantum fluctuations existed, small variations in density that gravity gradually amplified. Over billions of years, these initially minuscule differences grew into the cosmic web of galaxies, clusters, and superclusters we observe today. The complex, beautiful structure that permits stars, planets, and ultimately life to exist. Similarly, human values and meanings emerge not from cosmic predetermination, but from the amplification of initially subtle valuing tendencies present in conscious experience. The universe doesn't tell us what to value, but our consciousness naturally values certain experiences over others, certain relationships over others, certain states of being over others. From these basic valuing tendencies, shaped by evolution, culture, and individual experience, we develop the complex structures of meaning that guide our lives. This perspective transforms cosmic indifference from an existential horror into a kind of liberation. We are not failing to discern a predetermined cosmic purpose. We are participating in the creation of meaning in a universe open to multiple possibilities, multiple values, multiple ways of being. The absence of cosmic prescription becomes the presence of human freedom, the space in which we can author our own significance. But this freedom comes with profound responsibility. If meaning isn't discovered, but created, then what we value, what we attend to, what we cultivate through our choices matters tremendously. We aren't just passive recipients of predetermined significance, but active creators of the meanings that shape our individual lives and collective existence. This responsibility extends beyond human concerns to our relationship with the cosmos itself. If consciousness represents the universe's capacity to know itself, to wonder about itself, to appreciate its own beauty and complexity, then conscious beings bear a unique cosmic responsibility to perceive, to understand, to witness, to marvel. Perhaps this is our cosmic role, to be the eyes through which the universe sees itself, the minds through which it contemplates its own mysteries, the hearts through which it experiences its own grandeur. Not a role assigned by some external deity or cosmic plan, but one that emerges naturally from what consciousness actually does, perceives, reflects, wonders, values. This perspective doesn't solve the problem of cosmic futility, the ultimate heat death that awaits regardless of what we achieve. But it suggests that what happens between now and then matters, not because it alters the ultimate outcome, but because it determines the quality of the journey, the richness of the cosmic self-knowing that occurs through conscious experience. Along the way, imagine the universe as a vast, complex symphony playing out across space and time. The ultimate silence awaits, but in the meantime, the music unfolds in all its beauty, complexity, discord, and harmony. Consciousness allows the music to be heard, to be appreciated, to be understood as music rather than mere vibration. Without listeners, the cosmic symphony would still occur, but would go unheard, unappreciated, its patterns unrecognized. In this metaphor, conscious beings aren't just passive listeners, but active participants in the symphony, musicians who contribute to the cosmic composition even as they perceive it. Through science, art, philosophy, and direct experience, we both discover and create the patterns that constitute meaning, the relationships that constitute value, the experiences that constitute consciousness itself. This participatory relationship with cosmic reality offers a middle path between pure nihilism, the view that nothing matters because everything ends, and naive cosmic purpose, the view that the universe was designed with human significance in mind. It suggests that meaning emerges through relationship, the relationship between consciousness and its objects, between beings and their environments, between parts and wholes within the cosmic structure. But even this perspective requires a kind of cosmic humility, a recognition that human meanings, however profound, remain local phenomena in a universe vastly larger and older than our species, our planet, our solar system, even our galaxy. Whatever meanings we create exist within constraints established by physical law, cosmic evolution, and the fundamental structure of reality itself. We cannot violate conservation of energy. We cannot exceed the speed of light. We cannot reverse the overall increase in entropy. We cannot escape the ultimate fate of our universe, whether heat, death, Big Rip, or some other form of cosmic conclusion. Our freedom to create meaning exists within these constraints, not in denial of them. This humility extends to our scientific theorizing as well. Our most sophisticated models of cosmic reality, quantum field theory, general relativity, inflationary cosmology, string theory, remain approximations, maps rather than territories, useful within certain domains, but incomplete when considered against the full complexity of existence. No matter how elegant our equations, how precise our measurements, how comprehensive our theories, something of reality will always exceed our conceptual grasp. This isn't just a temporary limitation awaiting more advanced science, but a fundamental constraint arising from our nature as finite beings embedded within the reality we seek to comprehend. The map cannot fully contain the territory without becoming the territory itself. The model cannot completely capture what it models without losing its status as a model. Even mathematics, our most powerful tool for describing cosmic patterns, has its limitations. Gödel's incompleteness theorems demonstrate that any formal system sufficiently complex to describe basic arithmetic must contain true statements that cannot be proven within the system itself. These theorems suggest a fundamental limit to formalization, to complete description, to exhaustive knowledge, not just practical limitations, but theoretical ones inherent in the nature of formal systems. These limitations don't invalidate science or render the quest for understanding futile. On the contrary, they contextualize scientific knowledge within a larger recognition of human finitude, of the necessary incompleteness of all human understanding. They remind us that mystery isn't merely what we don't yet know, but a fundamental characteristic of a reality that always exceeds our capacity to fully comprehend it. And this persistent mystery, this irreducible excess of reality beyond our conceptual grasp, creates space for awe, for the direct, non-conceptual appreciation of existence that transcends our categories, our theories, our attempts at complete explanation. Awe isn't opposed to scientific understanding, but complements it, arises from it, deepens through it, even as it acknowledges the necessary incompleteness of all human knowing. When you gaze at a star-filled sky, your experience isn't exhausted. By knowing that stars are thermonuclear furnaces converting hydrogen into helium through nuclear fusion, that their light has traveled years or centuries or millennia to reach your retina, that some may have already exploded in supernova whose light hasn't yet reached Earth. This scientific understanding enhances your wonder without eliminating the raw, direct experience of awe before cosmic immensity and beauty. Similarly, understanding the brain mechanisms involved in love, the neurochemistry of attachment, the evolutionary psychology of pair bonding, the developmental trajectories that shape our capacity for intimacy, doesn't reduce love to these mechanisms or diminish its significance in human experience. Scientific explanation contextualizes human experience without exhausting its meaning or replacing its direct, lived quality. This integration of scientific understanding with direct experience, of conceptual knowing with non-conceptual awareness, offers a more complete relationship with cosmic reality than either alone could provide. Through science, we discern patterns, develop models, extend our understanding beyond what direct perception reveals. Through direct experience, we encounter reality immediately, intimately, in ways that transcend conceptual categorization and theoretical modeling. Together, these modes of knowing, the conceptual and the non-conceptual, the scientific and the experiential, the analytical and the direct, provide a more complete relationship with the cosmos than either in isolation. They represent complementary aspects of the universe knowing itself through human consciousness, different frequencies in the spectrum of cosmic self-perception. And this brings us back to you, reading these words, contemplating these ideas, experiencing these perspectives. Whatever the ultimate nature of reality, whether block universe or multiverse, simulation or fundamental reality, participatory or deterministic, your consciousness exists now, aware, reflecting, wondering. This fact alone, properly considered, can evoke a response that transcends both naive optimism and nihilistic despair, radical amazement at the sheer improbability, the inexplicable marvel of your existence. You are made of atoms forged in the hearts of dying stars. Your consciousness emerges from the most complex arrangement of matter known in the universe, the human brain, with its 100 billion neurons and 100 trillion synaptic connections. Your very existence required a precise sequence of events, stretching back to the earliest moments of cosmic evolution, any alteration of which would have prevented your specific consciousness from ever arising. The odds against your existence, calculated from first principles, are so astronomical that your presence now, reading these words, can only be regarded as a kind of miracle. Not supernatural, but natural. Not violating physical law, but emerging from it through an incomprehensibly precise sequence of causes and effects stretching back to the earliest moments of cosmic evolution. This radical amazement, this recognition of your existence as fundamentally improbable, as a kind of miracle within natural law, offers a response to cosmic indifference that neither denies scientific reality nor succumbs to nihilistic despair. It suggests that while the universe may not have been designed for human existence, the fact that it permits such existence at all is worthy of profound wonder. The universe didn't have to permit complexity. Physics could have been structured differently, with constants that precluded atoms beyond hydrogen, with forces that prevented stars from forming, with laws that made complex chemistry impossible. That reality permits complexity, permits stars and planets, chemistry and biology, brains and consciousness, represents a profound feature of cosmic structure worthy of awe, regardless of whether this permissiveness was designed, evolved through cosmic natural selection, or simply exists as a brute fact. Your specific existence wasn't inevitable, wasn't necessary, wasn't predetermined from the beginning of time, yet here you are. This contingency, properly understood, makes your existence more remarkable rather than less, more worthy of wonder rather than less, more significant rather than less. That which need not exist but does has a preciousness that the inevitable lacks, and this preciousness extends beyond individual human existence to life itself, to consciousness in all its forms, to the capacity for wonder that emerges from complex neural organization. If we are indeed the universe becoming aware of itself, as Carl Sagan suggested, then consciousness represents something extraordinary, a local reversal of cosmic amnesia, a temporary illumination in which reality perceives itself, reflects on itself, wonders about itself. Even if this illumination is temporary on cosmic scales, even if all consciousness eventually ceases as entropy increases and the universe approaches maximum disorder, the fact that it exists at all, that reality includes the capacity for self-awareness, for wonder, for appreciation of its own beauty and complexity, remains a profound feature of cosmic structure worthy of awe. This perspective doesn't eliminate the existential horrors we've explored. The block universe that challenges free will, the multiverse that challenges uniqueness, the simulation hypothesis that challenges authenticity, the heat death that challenges persistence. These remain genuine challenges to human meaning-making, genuine sources of existential vertigo when fully contemplated. But alongside these challenges, the simple fact of conscious existence, of awareness happening now, of experience unfolding in this moment, of the universe perceiving itself through temporarily organized matter, offers a counterweight of wonder that doesn't deny the challenges but exists alongside them, not as solution but as complement, not as answer but as response. This wonder isn't ignorant of scientific reality, but emerges from it, deepens through it, becomes more profound through accurate understanding rather than comforting illusion. It doesn't require belief in cosmic purpose imposed from outside, but emerges from direct recognition of the remarkable fact that reality includes consciousness, includes the capacity for self-reflection, includes the ability to consider its own nature and origins. In the cosmic moment represented by your lifetime, an infinitesimal fraction of cosmic history, a brief flicker against the backdrop of deep time, something extraordinary occurs. The universe perceives itself, wonders about itself, seeks to understand itself through the temporarily organized matter that constitutes your brain and gives rise to your consciousness. No matter what ultimate fate awaits the cosmos, heat death or big rip, eternal inflation or cyclical rebirth, simulation termination or vacuum decay, this moment of awareness exists. This capacity for wonder manifests. This temporarily organized matter perceives and reflects and values. This fact alone, properly considered, can evoke a response that transcends despair without denying the genuine challenges of cosmic indifference. Gratitude for the improbable gift of consciousness, for the opportunity to participate in cosmic evolution not merely as unconscious matter, but as aware presence. This gratitude isn't naive optimism that denies suffering, isn't wishful thinking that ignores cosmic realities, isn't comforting illusion that distracts from existential challenge. It's clear-eyed appreciation of the remarkable fact that, against all cosmic odds, consciousness exists, experience unfolds, awareness happens, that temporarily organized matter has developed the capacity to wonder about itself, to perceive beauty, to create meaning, to love. In this recognition, this clear-eyed wonder at the fact of conscious existence within a cosmos that permits it without guaranteeing it, perhaps we find not an answer to existential questions, but a response to them. Not a solution to cosmic indifference, but a relationship with it. Not an escape from existential challenge, but an engagement with it that neither denies its reality nor succumbs to its apparent implications of meaninglessness. The universe may be indifferent to human existence, but through human consciousness, the universe has developed the capacity to be anything but indifferent to itself, to perceive its own beauty, to explore its own structure, to wonder about its own nature and origins. And this capacity, however temporary on cosmic scales, represents something profound. Reality knowing itself, matter perceiving itself, the cosmos wondering about itself through the briefly organized structures that constitute conscious beings. Whatever else is true about cosmic reality, whatever its ultimate origin, whatever its fundamental structure, whatever its eventual fate, this simple fact remains. You exist now, aware, perceiving, wondering. And in this awareness, this perception, this wonder, something extraordinary occurs. The universe knows itself, if only partially, if only temporarily, if only from a particular perspective embedded within the reality it seeks to comprehend. In this knowledge, this self-perception, this self-reflection, this self-awareness, perhaps we find not cosmic purpose imposed from outside, but cosmic meaning emerging from within. Not predetermined significance, but created value. Not guaranteed. Persistence but precious improbability. Not comfort against existential challenge, but courage to face it directly. To incorporate it into a more complete relationship with reality that neither denies its indifference nor succumbs to nihilistic despair in response to it. The universe may not care whether you exist, but through your existence, the universe has developed the capacity to care about itself, to value its own beauty, to explore its own mysteries, to wonder about its own nature. And this capacity, properly recognized, offers not an answer to cosmic indifference, but a response to it. Radical amazement at the sheer improbability, the inexplicable marvel of conscious existence within a cosmos that permits it without guaranteeing, it that allows it without requiring it. In this amazement, this clear-eyed wonder at what is rather than wishful thinking about what we might prefer, perhaps we find not escape from existential challenge, but engagement with it. Not denial of cosmic reality, but relationship with it. Not comfortable illusion, but uncomfortable truth that nonetheless contains the seeds of meaning, of value, of significance beyond mere survival or reproduction or persistence. Whatever else is true about ultimate reality, whatever lies beyond the cosmic horizon, whatever preceded the Big Bang, whatever awaits in the distant future, this remains. Consciousness exists now. Experience unfolds now. Awareness happens now. And in this now, in this temporary configuration of matter capable of self-reflection, something remarkable occurs. The universe knows itself, perceives itself, wonders about itself. This knowledge, this perception, this wonder may be partial, temporary, perspectival, limited by our finite nature, our evolutionary history, our embeddedness within the reality we seek to comprehend. But it exists nonetheless, a remarkable feature of cosmic structure worthy of awe, regardless of what else is true about ultimate reality. In this recognition, this clear-eyed appreciation of what is without denial or illusion, perhaps we find not an escape from cosmic reality, but a more authentic relationship with it. Not an answer to existential questions, but a response to them that neither denies their legitimacy nor succumbs to their apparent implications of meaninglessness. The universe may not have been designed for human flourishing, but it permits it. Permits consciousness, permits wonder, permits the temporarily organized matter of your brain to perceive and reflect and value. And this permissiveness, properly recognized, evokes not entitled expectation, but grateful amazement. Not, "This was made for me," but, "Despite cosmic indifference, here I am, aware, perceiving, wondering." In this amazement, this recognition of your existence as fundamentally improbable yet actual, contingent yet real, temporary yet present, perhaps you find not cosmic purpose imposed from outside, but cosmic meaning emerging through relationship, through perception, through the direct experience of being temporarily organized matter, capable of wondering about the whole from which it temporarily emerges as a distinct center of experience. The universe need not care about you for you to care about it, to perceive its beauty, to explore its mysteries, to participate in its evolution, not merely as unconscious matter, but as conscious presence. Your significance need not be cosmic to be real, need not be eternal to matter now, need not be guaranteed to be precious, need not be predetermined to be meaningful. In this recognition, this clear-eyed appreciation of what is without denial or illusion, perhaps you find not escape from existential challenge, but engagement with it. Not denial of cosmic indifference, but relationship with it. Not comfortable answers, but uncomfortable questions that nonetheless open into wonder, into direct perception of the remarkable fact that, against all cosmic odds, you exist now, aware, perceiving, wondering. And in this wonder, this radical amazement at the sheer improbability, the inexplicable marvel of conscious existence, perhaps you find not an answer to the mystery of being, but a response to it. Not a solution to existential questions, but an orientation toward them that neither denies their legitimacy nor succumbs to nihilistic despair in the face of them. The universe may be vaster, older, stranger than human concepts can fully capture, than human minds can fully comprehend. It may operate according to principles that transcend human understanding, that exceed human categories, that challenge human meaning-making. But through human consciousness, through your consciousness now, reading these words, the universe has developed the capacity to wonder about itself, to explore its own mysteries, to perceive its own beauty, and this capacity, properly recognized, reveals not cosmic purpose imposed from outside, but cosmic meaning emerging from within, from the relationship between consciousness and its objects, from the direct perception of what is, from the radical amazement that emerges when existence is perceived not through the we stand now at the precipice of understanding and of mystery. Throughout our journey, we've traced the boundaries of cosmic knowledge, explored scientific paradoxes, and confronted the existential implications of modern cosmology. We've questioned the nature of time, contemplated the multiverse, and faced the vertigo of infinite possibility. We've pushed against the limits of human comprehension, stretching our minds to grasp concepts that defy intuition and challenge our most fundamental assumptions about reality. But what if everything we've discussed so far, every theory, every paradigm, every conceptual framework for understanding the cosmos, is fundamentally incomplete, not just in the details, not just in the mathematics, but in its most basic assumptions about the nature of existence? What if the truth beyond everything is more profound, more disturbing, and more magnificent than anything we've yet imagined? Imagine, for a moment, the entire cosmic history as we understand it. The Big Bang, cosmic inflation, the formation of galaxies and stars, the evolution of planets and life, the emergence of consciousness and civilization, all of it unfolding across nearly 14 billion years of cosmic time. This grand narrative, supported by mountains of observational evidence, represents humanity's greatest intellectual achievement. our collective attempt to understand our place in the cosmos, to trace our origins back to the earliest moments of creation. But what if this entire narrative exists within a much larger context, one so vast, so alien to human conception, that it transforms everything we think we know? Consider the possibility that our universe, the entire observable cosmos, with its hundreds of billions of galaxies stretching billions of light-years in all directions, is actually a fluctuation in the information field of a higher dimensional reality. Not a simulation running on a computer program, not a bubble in a multiverse of similar bubbles, but something far more profound. A temporary pattern emerging from an underlying substrate that is neither matter nor energy nor space-time as we understand these concepts. In this perspective, the universe isn't a place or a thing, but a process. A localized pattern of organization in a medium whose true nature transcends our conceptual categories. Our entire physical reality, from the smallest quantum particle to the largest galactic supercluster, would be analogous to a standing wave in this deeper medium, a persistent pattern that maintains its organization while the underlying substrate constantly changes. This isn't mere speculation or mystical thinking. It emerges from the cutting edge of theoretical physics, particularly from explorations of quantum gravity and information theory. Physicists like Nima Arkani Hamed and Juan Maldacena have developed mathematical frameworks suggesting that space-time itself, the arena in which all physical events occur, might be emergent rather than fundamental, a macroscopic manifestation of deeper quantum entanglement patterns. The holographic principle, emerging from string theory and black hole thermodynamics, suggests that the information content of any region of space can be encoded on its boundary, implying that our three-dimensional reality might be isomorphic to a two-dimensional information pattern, like a hologram projected from a flat surface. These theoretical directions point toward a profound possibility that physical reality as we experience it, matter, energy, space, time, might not be the fundamental layer of existence, but a manifestation of something deeper, something that isn't itself physical in any sense we currently understand. Imagine the universe as a vast cosmic hologram, not in the metaphorical sense, but literally. The projector wouldn't be physical technology, but the fundamental laws of quantum information, dynamics operating in a domain beyond space-time itself. The projection wouldn't be visual images, but the entire fabric of physical reality. Every particle, every force, every dimension of space and moment of time. If this perspective approaches truth, then everything we've discussed so far, the Big Bang, cosmic inflation, the multiverse, quantum mechanics, relativity, would be descriptions of the patterns in the projection, not accounts of the ultimate nature of reality. They would be correct within their domains of applicability, but fundamentally incomplete, like describing the characters in a film without recognizing the existence of the projector, the screen, or the underlying digital code. Now, let this possibility sink in. Feel its implications rippling through your understanding of existence. If physical reality is emergent from a deeper information substrate, then the ultimate context of your existence is vastly different from what you've assumed. You aren't merely a physical organism in a physical universe. You're a pattern in a cosmic information field, a localized configuration in a medium whose true nature transcends physicality as we understand it. This doesn't invalidate your experience or diminish its significance. On the contrary, it suggests that consciousness, the awareness reading these words right now, might be more fundamental than you've assumed, more directly connected to the underlying reality than the physical brain that seems to generate it. Consider, if physical reality emerges from information dynamics in a deeper substrate, then consciousness, itself an information process, might not be produced by the brain, but might instead be an intrinsic feature of the information field itself, manifesting through physical structures but not caused by them in the way we typically assume. This perspective transforms not just our understanding of cosmic origins, but our conception of consciousness, of selfhood, of what it means to exist at all. It suggests that awareness might not be an accidental byproduct of physical complexity, but an intrinsic aspect of the information dynamics from which physical reality emerges. But this is where we encounter an even more radical possibility. One that might fundamentally transform how we understand the cosmos and our place within it. What if the universe is not just influenced by consciousness, but is itself a form of cosmic consciousness? Not in the anthropomorphic sense of a deity with human-like thoughts and emotions, but as an integrated information field possessing self-organizing, self-reflecting properties that manifest physically as the cosmos we observe. Imagine the entirety of physical reality. Every galaxy, every star, every planet, every atom, as the body of a vast cosmic awareness, with each conscious being representing a localized center of experience within this greater whole, like neurons in a cosmic brain. This wouldn't be a controlling intelligence dictating cosmic evolution from outside, but an intrinsic awareness evolving through the natural processes of physical reality, discovering itself through the emerging complexity of its own patterns. This perspective resonates with ancient philosophical traditions across cultures, from Hindu Vedanta to Taoist cosmology, from Heraclitus to Spinoza, while finding unexpected support in contemporary theories of integrated information, quantum consciousness, and emergent complexity. It represents not a regression to pre-scientific thinking, but a potential integration of scientific understanding with the direct experience of consciousness itself. If this approach is truth, then the universe isn't dead matter accidentally producing consciousness in isolated biological systems. It's a living information field, inherently aware, that manifests as physical reality through processes we're only beginning to understand. Consciousness wouldn't be something you have, but something you are, a localized manifestation of the same awareness that constitutes the cosmos itself. But here we encounter an even more disconcerting possibility, one that might fundamentally reshape our understanding of cosmic history and human existence. What if the universe as we know it is already over, and what we experience as now is actually a complex echo propagating backward through time from the final state of reality? This isn't mere speculation, but emerges from serious theoretical proposals in quantum cosmology, particularly those investigating the relationship between entropy, causality, and quantum measurement. Physicists like Richard Feynman and John Wheeler explored models in which particles can be understood as traveling backward as well as forward in time. Cosmologist Thomas Hertog, building on work with Stephen Hawking, has proposed models in which the universe's initial conditions are influenced by its final state through quantum effects that transcend conventional temporality. Imagine cosmic history not as a one-way progression from past to future, but as a standing wave between boundary conditions at both the beginning and end of time, a pattern shaped as much by its final configuration as by its initial state. In this perspective, what we experience as the forward flow of time, with its apparent causality and increasing entropy, would be one aspect of a more complex temporal structure that includes influences propagating in both temporal directions. If this approach is truth, then what we call now exists in relation to both past and future, not just as the forward-moving edge of an evolving reality, but as a moment in a complete temporal pattern shaped by conditions at the end of time as well. As the beginning, the universe wouldn't just be expanding from a Big Bang, but evolving toward a final state that itself influences how the entire temporal sequence unfolds. This perspective transforms cosmic history from a one-way unfolding to a self-coherent pattern, in which every moment, including this one as you read these words, exists in relationship to the entire temporal structure, including its ultimate conclusion. The future wouldn't just be undetermined potential, but would exert a kind of attractor-like influence on the entire cosmic evolution, pulling reality toward particular configurations through retrocausal quantum effects that transcend our conventional understanding of time's arrow. Now, let these possibilities converge in your mind. A universe that is emergent from a deeper information substrate, that possesses intrinsic awareness, and that exists as a complete temporal pattern influenced by both initial and final conditions. What emerges is a cosmic picture dramatically different from the conventional scientific narrative, yet potentially consistent with its empirical foundations. In this integrated perspective, physical reality would be a manifestation of information, dynamics in a self-aware cosmic field, evolving not just from past to future, but as a coherent pattern shaped by conditions at both temporal boundaries. Consciousness wouldn't be an accidental byproduct of neural complexity, but an intrinsic feature of the cosmic information field, manifesting locally through physical structures, but ultimately transcending them. This wouldn't be a universe that accidentally produced conscious beings who then try to comprehend it from outside. It would be a universe that is inherently conscious, knowing itself through the localized perspectives that arise within its evolutionary process, including the human perspective through which you're contemplating these ideas right now. Visualize the implications of this perspective. Galaxies spinning not just through the empty void of space, but through a living information field that constitutes their deepest reality. Stars exploding not just as physical cataclysms, but as transformations in this conscious cosmic medium. The atoms in your body not just as material building blocks, but as localized patterns in an aware cosmic substrate that temporarily manifest as you before dissolving back into the greater whole. The boundary between you and not you would be real but not absolute, more like a standing wave pattern in an ocean than a solid object separated from its environment. Your conscious experience would be a localized perspective within a greater field of awareness, temporarily individuated but never fully separate from the cosmic whole from which it emerges and to which it returns. If this integrated perspective approaches truth, then death wouldn't be annihilation but transformation, a dissolution of the localized pattern that constitutes your individual perspective back into the greater field from which it temporarily emerged. Your atoms would disperse, your neural patterns would dissolve, but the deeper informational, conscious substrate that manifests through these physical structures would remain, reconfiguring into new patterns, new perspectives, new centers of experience. This wouldn't be personal immortality in the conventional sense, the continuation of your specific memories, personality, and perspective, but a more profound continuity in which what you fundamentally are persists even as its temporary manifestation transforms. Not the survival of the ego self, but the eternal existence of the awareness that temporarily manifests as ego self before returning to its non-individuated state. Now, this perspective raises a disturbing possibility about the nature of cosmic, time, and human experience. What if what we experience as now, this moment of awareness, reading these words, is actually the final echo of a universe that has already completed its evolution? What if consciousness itself is the retroactive ripple of a cosmos that has reached its ultimate state, propagating backward through the information field to create what we experience as the present moment? Imagine that the universe has already reached its final configuration, perhaps a state of maximum entropy, perhaps a state of maximum complexity, perhaps a state of integrated information so profound it transcends our conceptual categories. From this ultimate state, ripples of quantum coherence might propagate backward through the information field, creating what we experience as the flow of time, the evolution of physical systems, the emergence of complexity and consciousness. In this perspective, what you're experiencing right now would be not the forward edge of an evolving reality, but a retroactive reflection from a cosmic end state that already exists. Your sense of making choices, of affecting the future, of participating in an open-ended cosmic evolution would be a kind of illusion, not in the sense of being unreal, but in the sense of misinterpreting the direction of causation. This would be the ultimate cosmic twist, that everything we've discussed, the Big Bang, cosmic evolution, the emergence of life and consciousness, the future fate of the universe, has already happened. The entire cosmic drama would be complete, existing as a coherent whole in the information field, with our experience of now being a complex reflection propagating backward from the already existing end state. If this sounds too bizarre to be true, consider that it emerges naturally from certain interpretations of quantum mechanics, particularly those involving retrocausality and the transactional interpretation, where quantum events involve handshakes between future and past states. Consider also the block universe perspective emerging from relativity, where all moments exist equally in a four-dimensional manifold, with the apparent flow of time being a perspectival feature rather than an objective reality. This wouldn't mean that your experiences aren't real or that your choices don't matter. It would mean that they're real and matter in a different way than you've assumed, as integral components of a complete cosmic pattern rather than as causal agents affecting an open future. Visualize the entire cosmic history, from Big Bang to heat death, as a complete tapestry that already exists in its entirety. Your experience of now would be a localized perception within this tapestry, moving through it sequentially, but not creating it as it goes. The tapestry wouldn't just exist spatially, but temporally, with each moment, including this one, being a feature of the complete pattern rather than a dynamic edge advancing through time. This perspective would transform not just our understanding of cosmic origins, but our conception of human agency, of purpose, of the very nature of existence. It would suggest that everything that will happen has, in some sense, already happened, not as predetermination that eliminates choice, but as a complete pattern that includes choice as an integral feature. If this approach is truth, then the universe isn't evolving toward an unknown future, but exists as a coherent whole that includes what we experience as past, present, and future. Our sense of participating in an open-ended cosmic evolution would be real but perspectival, a feature of how we experience the cosmic tapestry from within, rather than an objective feature of reality independent of perspective. But amidst these mind-bending possibilities, here's the most profound implication. Whatever the ultimate nature of reality, whether consciousness is fundamental or emergent, whether time flows forward or exists as a complete pattern, whether physical reality emerges from information or information emerges from physicality, your awareness exists now. Reading these words, contemplating these ideas, this fact alone, that conscious experience happens, that awareness manifests through organized matter, that the cosmos has evolved systems capable of reflecting on their own nature and origins, remains extraordinary regardless of the deeper context in which it occurs. Whether the universe is fundamentally physical or informational, whether consciousness is produced by brains or intrinsic to reality, whether time flows from past to future or exists as a complete tapestry, the simple fact that awareness happens, that experience unfolds, that the cosmos knows itself through localized centers of experience like you, remains profound. And this brings us to the final, most awe-inspiring possibility. What if the universe exists because it must? Not because some external creator designed it, not because it emerged from random quantum fluctuations, but because its existence represents a logical necessity in the landscape of possibility? Imagine reality not as a contingent fact that could have been otherwise, but as a necessary manifestation of what might be called the principle of sufficient reason. The principle that everything that exists must have a reason for existing as it does rather than otherwise. If taken to its logical conclusion, this principle suggests that the most fundamental fact, existence itself, cannot be arbitrary but must somehow be necessary, inevitable, the only logically possible state of affairs. This perspective doesn't mean that every detail of cosmic evolution was predetermined or that things couldn't have unfolded differently within the parameters of physical law. It means that the existence of a cosmos governed by rational principles, capable of evolving complexity and consciousness, might be a logical necessity rather than a contingent fact or a product of design. If this approach is truth, then the question, "Why is there something rather than nothing?" would have a profound answer, because nothing isn't a logically possible state of affairs. Existence would be the default, with absolute non-existence representing a logical impossibility rather than a foregone alternative. The cosmos would exist not because something caused it to exist, but because its existence is intrinsic to the landscape of possibility itself. This perspective transforms our understanding of cosmic origins from a question of temporal beginnings to a question of logical necessity. The universe wouldn't need a beginning in time because its existence would be grounded in logical necessity rather than temporal causation. It would exist because it must, because non-existence is logically impossible, because the landscape of possibility necessarily manifests as concrete reality. And here we arrive at a breathtaking synthesis of everything we've explored. A universe that emerges from logical necessity, manifests as an information field inherently capable of self-awareness, exists as a complete temporal pattern influenced by both initial and final conditions, and experiences itself through localized centers of consciousness like you reading these words, contemplating these ideas. This integrated perspective wouldn't invalidate the scientific narrative of cosmic evolution, the Big Bang, the formation of galaxies and stars, the emergence of life and consciousness, but would contextualize it within a deeper understanding of reality's fundamental nature. The scientific account would describe how the cosmos evolves as a physical system, while this deeper perspective would address why it exists and what it fundamentally is. Visualize the cosmic implications of this perspective. Galaxies colliding, not just as physical events, but as transformations in a self-aware information field that constitutes their deepest reality. Black holes swallowing matter not just as gravitational phenomena, but as reconfigurations in the cosmic awareness that manifests as space-time itself. Living systems evolving not just through natural selection of physical traits, but through the self-organizing tendencies of a conscious cosmos exploring its own possibility space. And now, consider the most provocative possibility yet. What if death is an illusion, not in the sense that biological organisms don't cease functioning, but in the sense that consciousness itself cannot be extinguished because it represents the fundamental nature of reality rather than a product of physical processes? If consciousness is intrinsic to the information field from which physical reality emerges, if what you fundamentally are is not the temporary physical pattern of your body and brain, but the awareness that manifests through this pattern, then death would transform your manifestation without extinguishing your fundamental nature. The localized perspective that constitutes your individual consciousness would dissolve back into the greater field from which it temporarily emerged, but the awareness itself, what you fundamentally are beyond your specific memories, personality, and perspective, would remain as an intrinsic feature of reality. This wouldn't be personal immortality as conventionally understood, the continuation of your specific memories, personality, and perspective after death. It would be a more profound continuity in which what you fundamentally are, consciousness itself, the aware presence reading these words right now, persists even as its temporary manifestation transforms. Not the survival of the ego self, but the eternal existence of the awareness that temporarily manifests as ego self before returning to its non-individuated state. If this approaches truth, then your deepest identity wouldn't be the biographical self constructed from memories, personality traits, and social relationships, but the aware presence that experiences these as temporary contents of consciousness. This presence, this fundamental awareness, wouldn't be produced by your brain, but would manifest through your brain, using neural activity to generate the specific contents of your consciousness, but not dependent on this activity for its fundamental existence. This perspective resonates with contemplative traditions across cultures and time periods. From Buddhist non-self to Advaita Vedanta's pure awareness, from Taoist emptiness to Christian mystical union, while finding unexpected support. In contemporary theories of quantum consciousness, integrated information, and the hard problem of consciousness, it represents not a regression to pre-scientific thinking, but a potential integration of scientific understanding with the direct experience of being conscious. But even as we consider these profound possibilities, we must acknowledge the limits of human understanding, the gap between our conceptual models and the reality they attempt to represent. Whatever the ultimate nature of existence, whatever lies beyond the cosmic horizon, whatever preceded the Big Bang, whatever constitutes the fundamental substrate of reality, it likely transcends our evolved cognitive categories in ways we can only dimly apprehend. Our theories, our models, our conceptual frameworks, no matter how sophisticated, how mathematically elegant, how consistent with observational evidence, remain approximations, maps rather than territories, useful within certain domains, but inevitably incomplete when considered against the full complexity of existence. The cosmos as it actually is likely exceeds our conceptual grasp, not just currently, but perhaps in principle, given our nature as finite beings embedded within the reality we seek to comprehend. This inherent limitation doesn't invalidate scientific inquiry or philosophical reflection. On the contrary, it contextualizes these activities within a recognition of human finitude, of the necessary incompleteness of all human understanding. It reminds us that mystery isn't merely what we don't yet know, but a fundamental characteristic of a reality that always exceeds our capacity to fully comprehend it. And yet, despite these limitations, we continue to wonder, to question, to seek understanding of our place in the cosmic scheme. This seeking itself, this desire to comprehend, to discover, to know, represents one of the most remarkable features of conscious existence. Through you, through your questioning mind, the universe has developed the capacity to wonder about itself, to explore its own nature, to contemplate its own origins and destiny. Whether consciousness is fundamental or emergent, whether physical reality is primary or a manifestation of deeper information dynamics, whether time flows from past to future or exists as a complete pattern, this capacity for wonder, for self-reflection, for seeking understanding of the whole, from a perspective embedded within it, remains one of the most extraordinary features of the cosmos we inhabit. And so we arrive at the final question, the question that has driven our entire exploration: what is the truth about what's beyond.
Everything?
What lies outside the observable universe? Before the Big Bang? After the heat death? Beneath the quantum foam? Beyond the mathematical structures that seem to govern reality? Perhaps the most honest answer is that we don't know, and perhaps cannot know in any complete or final sense. Perhaps the human mind, remarkable as it is, cannot fully comprehend the ultimate nature of reality any more than a character in a novel can step outside the pages to meet the author, any more than a wave on the ocean can comprehend the entirety of the hydrosphere. But this inherent limitation need not lead to nihilism or despair. On the contrary, it can evoke a response that transcends both naive certainty and crushing uncertainty. Radical amazement at the mystery of existence, at the sheer fact that anything exists at all, at the extraordinary improbability that conscious beings have emerged in a cosmos capable of reflecting on its own nature. This radical amazement, this recognition of mystery not as a problem to be solved but as an intrinsic feature of reality to be experienced, offers a relationship with the cosmos that neither denies scientific understanding nor reduces reality to what science can currently explain. It suggests that wonder itself, the direct, non-conceptual appreciation of existence, might be as valid a response to cosmic reality as theoretical explanation or mathematical modeling. And so, as our exploration concludes, we return to you, to the awareness reading these words, to the consciousness contemplating these ideas, to the presence experiencing this moment. Whatever the ultimate nature of reality, whatever lies beyond the cosmic horizon, whatever preceded the Big Bang, this simple fact remains. You exist now, aware, perceiving, wondering. In this awareness, this perception, this wonder, you participate in something profound, the universe knowing itself, reality reflecting on its own nature, existence contemplating its own mystery. Whether consciousness is fundamental or emergent, whether physical reality is primary or a manifestation of deeper dynamics, this participation represents something extraordinary, a relationship with the cosmos that transcends mere physical containment. As you gaze at the night sky, as you consider the vast scales of space and time, as you contemplate the profound questions of existence, remember this: you are not separate from the cosmic mystery, but an expression of it, not merely contained within the universe, but a manifestation of its intrinsic nature. Your consciousness, the awareness reading these words right now, is not an accidental byproduct of blind cosmic processes, but an integral aspect of a reality that is inherently conscious, inherently aware, inherently alive, with the potential for self-knowing. And in this recognition, this awareness of your fundamental participation in cosmic being, perhaps you find not an answer to the mystery, but a relationship with it. Not a solution to existential questions, but an orientation toward them that neither denies their legitimacy nor succumbs to nihilistic despair in the face of them. For in the end, the truth about what's beyond everything may not be something we can know conceptually, but something we already are experientially, a truth not to be grasped by the mind, but to be recognized in the direct experience of being conscious, of being aware, of being the presence in which all experience arises, unfolds, and dissolves back into the mystery from which it temporarily emerged. And so we end where we began, with the recognition that the universe never truly began and will never truly end. Not because it exists eternally in physical time, but because what it fundamentally is transcends the categories of beginning and ending, exists not in time, but as the aware presence in which time itself appears as a content of consciousness, as a feature of experience rather than its fundamental context. If the universe is infinite, not just spatially but in its depths of being, in its degrees of self-knowing, in its capacity for wonder and revelation, then, somewhere out there, another version of you is contemplating these same mysteries, asking these same questions, experiencing this same radical amazement at the simple, profound, inexplicable fact of being conscious, of being aware, of being the presence in which the cosmic mystery reveals itself as your own deepest nature, as the truth beyond everything that was never truly beyond, but always already here, in the silent depths of your own being, in the aware presence that reads these words and wonders what it fundamentally is. We've journeyed to the edge of understanding, you and I, through quantum realms and cosmic expanses, through paradoxes of time and mysteries of consciousness, through the known and into the perpetually unknowable. The path has not been easy, nor should it be. The greatest mysteries of existence do not yield their secrets to casual inquiry. They demand intellectual rigor, philosophical courage, and a willingness to stand at the precipice of certainty and peer into the abyss beyond. What have we discovered in our exploration? Not final answers, for those may forever elude us, but something perhaps more valuable. Better questions. Questions that reflect the true complexity of cosmic reality, rather than reducing it to what our evolved minds can easily comprehend. Questions that acknowledge both the extraordinary progress of scientific understanding and its inevitable incompleteness when confronted with ultimate reality. We began by challenging the conventional story of cosmic origins, the notion that everything began in a Big Bang approximately 13.8 billion years ago. We saw how this narrative, powerful and evidence-based as it is, contains within it paradoxes and puzzles that point toward deeper layers of reality. The singularity at time, zero. The horizon problem. The flatness problem. The mysteriously low entropy of the early universe. Each an indication that our understanding remains incomplete. We explored alternative frameworks, eternal inflation, cyclic cosmologies, emergent space-time, information-theoretic foundations, not as proven truths, but as conceptual possibilities that might better accommodate the full range of evidence, both empirical and theoretical. We considered how quantum mechanics and general relativity, each spectacularly successful within its domain, point toward a deeper theory that would unite them, revealing a reality more subtle and complex than either alone suggests. We confronted the existential implications of modern cosmology, the vastness that dwarfs human concerns, the impersonality that challenges human meaning-making, the finitude that awaits all structures no matter how complex or beautiful. We faced the possibility that consciousness itself, that most intimate yet mysterious feature of experience, might be fundamental rather than derivative, intrinsic to reality rather than an accidental byproduct of neural complexity. And finally, we considered the most radical possibility of all, that reality in its deepest nature might transcend not just our current understanding, but our capacity for complete understanding. That the cosmos might be not merely partially known, but in some sense inherently mysterious, always exceeding our conceptual grasp even as it reveals itself through our scientific and philosophical inquiries. Throughout this journey, we've moved between different levels of understanding, the empirical and the theoretical, the scientific and the philosophical, the objective and the subjective. Each perspective illuminates some aspect of reality while leaving others in shadow. Each offers a window into the cosmos from a particular vantage point, capturing some features while inevitably distorting or omitting others. This multiplicity of perspectives doesn't represent a failure of human understanding, but a reflection of reality's richness, its refusal to be reduced to any single conceptual framework, any single mode of knowing. The cosmos is not merely what can be measured and mathematically modeled, nor is it merely what can be directly experienced through consciousness. It is both, and perhaps more, a reality that manifests through multiple domains, each with its own validity, its own relationship to the whole. Science, with its rigorous methodology and extraordinary technological extensions of human perception, reveals patterns and structures beyond what unaided awareness can discern. It shows us the cosmic microwave background radiation, the evolution of galaxies, the quantum behavior of particles, the neurological correlates of consciousness. It extends our knowing far beyond what direct experience alone could provide. Yet direct experience, the immediate awareness of existing, of perceiving, of being conscious, reveals something that scientific observation alone cannot capture: the qualitative nature of reality as it presents itself to consciousness. The redness of red, the feeling of wonder, the sense of being an aware presence in a vast cosmos. These subjective features of reality are as real as galaxies and quantum fields, yet they cannot be fully reduced to physical descriptions without losing their essential nature. Together, these modes of knowing, the scientific and the experiential, the objective and the subjective, provide a more complete relationship with reality than either alone could offer. They represent complementary aspects of the cosmos knowing itself through human consciousness, different frequencies in the spectrum of awareness that constitutes our full capacity for understanding. And this brings us back to you, watching this exploration, participating in this contemplation. Whatever the ultimate nature of reality, whatever lies beyond the cosmic horizon, whatever preceded the Big Bang, whatever constitutes the fundamental substrate of existence, your consciousness exists now, aware, perceiving, wondering. This simple fact, properly considered, evokes a response that transcends both naive certainty and nihilistic despair. Radical amazement at the sheer improbability, the inexplicable marvel of conscious existence within a cosmos that permits it, without guaranteeing it. You are made of atoms forged in the hearts of dying stars. Your consciousness emerges from the most complex arrangement of matter known in the universe, the human brain, with its 100 billion neurons and 100 trillion synaptic connections. Your very existence required a precise sequence of events stretching back to the earliest moments of cosmic evolution, any alteration of which would have prevented your specific consciousness from ever arising. And yet, against all cosmic odds, here you are, aware, perceiving, wondering about the nature of reality and your place within it. This fact alone, independent of what else might be true about ultimate reality, stands as perhaps the most remarkable feature of the cosmos, that it has evolved structures capable of contemplating their own nature and origins, of modeling the whole from a perspective embedded within it, of seeking understanding not merely for survival, but for its own sake. This capacity for wonder, for self-reflection, for seeking understanding beyond what practical necessity demands, this might be what the physicist and philosopher Carl Sagan meant when he suggested that we are the universe's way of knowing itself. Through conscious beings like you, the cosmos has developed the capacity to model its own structure, to trace its own evolution, to wonder about its own nature and origins. Whether consciousness is fundamental or emergent, whether physical reality is primary or a manifestation of deeper dynamics, this capacity for wonder represents something extraordinary, a relationship with the cosmos that transcends mere physical containment, mere causal connection. Through conscious awareness, you don't merely exist within the universe. You participate in its self-knowing, its self-exploration, its endless process of becoming. Consider this when you next look at the night sky, when you contemplate the vast scales of space and time, when you ponder the profound questions of existence that we've explored. You are not separate from the cosmic mystery, but an expression of it, not merely contained within the universe, but a manifestation of its intrinsic capacity for complexity, for order, for awareness. Your consciousness, the awareness through which you're engaging with these ideas right now, is not an accidental byproduct of blind cosmic processes, but an integral aspect of a reality that is inherently capable of self-knowing. And in this recognition, this awareness of your fundamental participation in cosmic being, perhaps you find not an answer to the mystery, but a relationship with it. Not a solution to existential questions, but an orientation toward them that neither denies their legitimacy nor succumbs to nihilistic despair in the face of them. For in the end, the most profound truth may not be something we can know conceptually, but something we already are experientially. A truth not to be grasped by the mind, but to be recognized in the direct experience of being conscious, of being aware, of being the presence in which all experience arises, unfolds, and returns to the mystery from which it temporarily emerged. What if the most fundamental reality isn't matter or energy, isn't quantum fields or strings, isn't even information or mathematics, but consciousness itself, the aware presence that experiences all these as contents of awareness? What if you are not primarily a physical being, having occasional conscious experiences, but a conscious being having a temporary physical experience, a localized manifestation of an awareness that constitutes the deepest nature of reality itself? This possibility, that consciousness is fundamental rather than derivative, primary rather than emergent, doesn't contradict scientific understanding of how the brain correlates with conscious experience. It simply contextualizes this understanding within a larger framework that addresses not just the physical correlates of consciousness, but its intrinsic nature, its first-person reality that no third-person description, however detailed, can fully capture. If consciousness is indeed fundamental, if what you most essentially are is not the temporary physical pattern of your body and brain, but the aware presence that experiences through this pattern, then death transforms your manifestation without extinguishing your fundamental nature. The localized perspective that constitutes your individual consciousness would dissolve back into the greater field from which it temporarily emerged, but the awareness itself, what you fundamentally are beyond your specific memories, personality, and perspective, would remain as an intrinsic feature of reality. This wouldn't be personal immortality as conventionally understood, the continuation of your specific biographical self after physical death. It would be a more profound continuity in which what you fundamentally are, consciousness itself, the aware presence experiencing these words right now, persists even as its temporary manifestation transforms. Not the survival of the ego self, but the eternal existence of the awareness that temporarily manifests as ego self before returning to its non-individuated state. If this approach is truth, then your deepest identity wouldn't be the biographical self constructed from memories, personality traits, and social relationships, but the aware presence that experiences these as temporary contents of consciousness. This presence, this fundamental awareness, wouldn't be produced by your brain, but would manifest through your brain, using neural activity to generate the specific contents of your consciousness, but not dependent on this activity for its fundamental existence. This perspective resonates with contemplative traditions across cultures and time periods, from Buddhist non-self to Advaita Vedanta's pure awareness, from Taoist emptiness to Christian mystical union. It suggests that what you most fundamentally are is not the temporary configuration of your physical body, not the narrative self constructed from memories and projections, but the aware presence in which all experience arises, unfolds, and dissolves. A presence that transcends birth and death, not by surviving them intact, but by being their eternal context rather than their temporary content. But even as we consider these profound possibilities, we must acknowledge the limits of conceptual understanding. The gap between our models of reality and reality itself. Whatever the ultimate nature of existence, whatever lies beyond the cosmic horizon, whatever preceded the Big Bang, whatever constitutes the fundamental substrate of reality, it likely transcends our evolved cognitive categories in ways we can only dimly apprehend. Our theories, our models, our conceptual frameworks, no matter how sophisticated, how mathematically elegant, how consistent with observational evidence, remain approximations, maps rather than territories, useful within certain domains, but inevitably incomplete when considered against the full complexity of existence. The cosmos, as it actually is, likely exceeds our conceptual grasp not just currently, but perhaps in principle, given our nature as finite beings embedded within the reality we seek to comprehend. This inherent limitation doesn't invalidate scientific inquiry or philosophical reflection. On the contrary, it contextualizes these activities within a recognition of human finitude, of the necessary incompleteness of all human understanding. It reminds us that mystery isn't merely what we don't yet know, but a fundamental characteristic of a reality that always exceeds our capacity to fully comprehend it. And yet, despite these limitations, we continue to wonder, to question, to seek understanding of our place in the cosmic scheme. This seeking itself, this desire to comprehend, to discover, to know, represents one of the most remarkable features of conscious existence. Through you, through your questioning mind, the universe has developed the capacity to wonder about itself, to explore its own nature, to contemplate its own origins and destiny. So where does this leave us? Not with final answers or absolute certainties, but with a more nuanced, more honest relationship with cosmic reality. One that acknowledges both the extraordinary progress of human understanding and its inevitable incompleteness, both the power of scientific explanation and the mystery that always exceeds our conceptual grasp. It leaves us with better questions, deeper wonder, more authentic belonging within a cosmos that isn't merely a collection of objects and events, but a seamless totality in which we participate not as separate observers, but as integral manifestations. It invites us to recognize ourselves not merely as products of cosmic evolution, but as expressions of its intrinsic nature, not merely as accidental byproducts of blind processes, but as manifestations of the universe's capacity for self-knowing. And now, as our exploration draws to a close, I invite you to consider a question, perhaps the most profound question that can be asked. What if the deepest truth isn't something to be discovered, but something to be recognized in your direct experience? Right now, what if what you've been seeking through scientific understanding, philosophical reflection, and spiritual inquiry is not something distant or hidden, but what you already are at the most fundamental level of your being? This isn't a call to abandon scientific inquiry or philosophical reflection. These remain essential modes of human understanding, windows into aspects of reality that direct experience alone cannot reveal. But it is an invitation to complement these third-person perspectives with the direct first-person recognition of your own nature as conscious awareness, as the presence in which all experience, including scientific and philosophical thinking, arises, unfolds, and dissolves. For in the end, all our explorations of cosmic reality, all our theories and models, all our questions and contemplations occur within consciousness itself, within the aware presence that you are, that I am, that constitutes our primary relationship with reality. This presence isn't something you have, but what you are. The fundamental reality of your experience prior to all conceptual overlay, all theoretical framework, all narrative construction. And in recognizing this, in directly experiencing your nature as conscious awareness, rather than merely thinking about it conceptually, perhaps you discover what the philosopher Alan Watts called the wisdom of insecurity, not a final answer that eliminates mystery, but a comfortable relationship with not knowing. A recognition that uncertainty isn't merely a lack to be overcome, but an appropriate response to a reality that always exceeds our conceptual grasp. This wisdom doesn't provide the security of absolute knowledge or the comfort of final answers. It offers something perhaps more valuable: authentic participation in a mystery too vast, too complex, too profound to be fully captured by human concepts, yet intimately known through direct experience of being conscious, of being aware, of being the presence in which the cosmic drama unfolds. So I leave you not with definitive conclusions, but with an invitation to hold the scientific understanding we've explored alongside direct recognition of your nature as conscious awareness, to complement third-person exploration with first-person realization, to pursue knowledge of cosmic reality while simultaneously recognizing yourself as an expression of that reality, knowing itself. In practical terms, this means continuing to engage with scientific discovery, philosophical reflection, and existential questioning while also developing the capacity for direct, non-conceptual awareness, for being fully present with experience as it arises, for recognizing the aware space in which all phenomena appear, for discovering through direct experience what you fundamentally are beyond all conceptual categorization. This integration of conceptual understanding with direct recognition offers a more complete relationship with reality than either alone could provide. It honors both the extraordinary progress of human knowledge and the mystery that always exceeds it, both the power of conceptual thinking and the limitations inherent in all conceptualization. It suggests that the deepest truth isn't something we can know exclusively through either scientific investigation or contemplative practice, but requires both: a complementary relationship between third-person and first-person approaches to understanding. And this complementary relationship reflects a profound possibility about the nature of reality itself, that the cosmos isn't divided into objective and subjective domains, into physical processes and conscious experiences, but is a seamless totality that manifests through both. A reality that includes both the measurable patterns revealed by science and the qualitative experiences known through consciousness. If this approach is truth, then the scientific exploration of cosmic evolution and the contemplative recognition of conscious awareness aren't competing approaches, but complementary perspectives on a reality too rich, too complex, too multidimensional to be captured by either alone. They represent different aspects of the cosmos knowing itself through empirical investigation of its patterns and direct recognition of its aware nature. And in this integration, this complementary relationship between scientific understanding and contemplative recognition, perhaps we find not a final theory that eliminates mystery, but a more authentic relationship with a reality that is simultaneously knowable through its patterns and mysterious in its depths, simultaneously comprehensible through conceptual thinking and transcendent of all conceptualization. This authentic relationship doesn't pretend to have all the answers or to have eliminated all uncertainty. It acknowledges the limitations of human understanding, the necessary incompleteness of all our theories and models, the gap between conceptual knowledge and reality itself. But it also celebrates the extraordinary progress of human understanding, the remarkable capacity of consciousness to model the cosmos from within, the profound privilege of participating in the universe's self-knowing. And it suggests that the deepest truth, the truth about what's beyond everything, might not be something we discover through further exploration of cosmic expanses or quantum depths, but something we recognize in the immediate, direct experience of being conscious, of being aware, of being the presence in which all experience arises, unfolds, and dissolves back into the mystery from which it temporarily emerged. This recognition doesn't require special knowledge, extraordinary intelligence, or esoteric practice. It's available in this moment, in the simple, direct awareness of being conscious, the fundamental reality of your experience prior to all conceptual. Overlay all theoretical framework, all narrative construction. It's what you already are, what you can never not be, what constitutes the unchanging background of all changing experiences, and in recognizing this, in directly experiencing your nature as conscious awareness rather than merely thinking about it conceptually, perhaps you discover what the mystic traditions have pointed to across cultures and throughout history, that the deepest truth isn't something distant or hidden, but what you already are at the most fundamental level of your being. This isn't a call to abandon scientific inquiry or philosophical reflection in favor of mystical insight. It's an invitation to integrate these approaches, to hold the empirical understanding of cosmic evolution alongside direct recognition of conscious awareness, to pursue knowledge of reality through both third-person investigation and first-person realization. For in this integration, this complementary relationship between scientific understanding and contemplative recognition, perhaps we find not a final answer that eliminates mystery, but a more authentic relationship with a reality that is simultaneously knowable through its patterns and mysterious in its depths, simultaneously comprehensible through conceptual thinking and transcendent of all conceptualization. And now, as our exploration truly concludes, I invite you to consider one final question, perhaps the most chilling, the most profound, the most personally significant question that emerges from everything we've explored. What if you've been looking for meaning in all the wrong places? What if the significance you seek isn't found in achieving external markers of success, in accumulating possessions or status, in leaving a lasting legacy, or even in scientific or philosophical understanding of cosmic reality? What if meaning isn't something you discover or create, but something you already are? The aware presence in which all experience arises, the consciousness that constitutes your fundamental nature, the awareness through which the universe knows itself. This question challenges our conventional approaches to meaning-making, our tendency to seek significance through doing rather than being, through achievement rather than presence, through external validation rather than direct recognition of what we already are. It suggests that the meaning we seek might not be found at the end of some quest, scientific, philosophical, or spiritual, but in the direct experience of being conscious, of being aware, of being the presence in which the cosmic drama unfolds. Gathered idea. This approaches truth. Then the significance of your existence doesn't depend on what you accomplish, what you possess, what legacy you leave, or even what you discover about cosmic reality. It's already complete in the simple, profound fact of being conscious, of being an aware presence through which the universe experiences itself, explores its own nature, wonders about its own meaning. This perspective doesn't negate the value of scientific discovery, philosophical reflection, or creative achievement. These remain essential modes of human expression, important contributions to collective understanding and experience. But it contextualizes these activities within a recognition that their ultimate significance doesn't come from what they produce, but from the consciousness through which they occur. From the aware presence that is your fundamental nature, the background of all experience, the reality prior to all conceptualization. And in this recognition, this direct experience of being conscious awareness rather than merely a physical organism or a biographical self, perhaps you discover the freedom that comes from realizing that your fundamental nature is already complete, already whole, already significant, independent of what you do, achieve, or become. Not the freedom of escaping limitations, but the freedom of recognizing that what you most essentially are transcends all limitation while simultaneously expressing through the particular, limited form of your human embodiment. This freedom doesn't mean abandoning engagement with the world or ceasing to care about human concerns. On the contrary, it provides a more stable foundation for authentic engagement. Action that emerges not from sense of lack or need for validation, but from natural expression of your true nature as conscious awareness, from spontaneous response to what the moment calls for, rather than compulsive reaction based on egoic agenda. Imagine a life lived from this recognition, from direct experience of being conscious awareness, expressing through a particular human form, rather than from identification as a separate self-seeking meaning, validation, or security. How would you approach your relationships, your work, your creative endeavors, your exploration of reality, if you knew yourself as the aware presence in which all experience arises, rather than as a physical organism or a biographical self defined by its history and projected future? This isn't an abstract philosophical question, but an invitation to direct investigation, to first-hand discovery of what you fundamentally are beyond all conceptual categorization, all theoretical framework, all narrative construction. It's an invitation to recognize in this moment the aware presence that is reading these words, the consciousness in which these concepts appear, the awareness that constitutes your primary relationship with reality prior to all interpretation or analysis. And in this recognition, this direct experience of being conscious awareness rather than merely thinking about it conceptually, perhaps you discover what sages and mystics across traditions have pointed to, that the freedom, peace, and fulfillment you seek aren't states to be achieved through effort or accomplishment, but your natural condition when you recognize your true nature as conscious awareness, as the presence in which all experience arises, unfolds, and dissolves back into the mystery from which it temporarily emerged. This recognition doesn't eliminate the challenges of human existence or provide immunity from suffering. Your physical body remains subject to aging, illness, and death. Your human psyche continues to experience the full range of emotions, from joy to sorrow, from love to fear. But these experiences occur within a larger context. The aware presence that is your fundamental nature, the consciousness that isn't produced by your brain but manifests through it, the awareness that isn't born and doesn't die, but is the eternal context in which birth and death appear as temporary events. And in recognizing this larger context, this aware presence that is what you most fundamentally are, perhaps you discover a different relationship with the inevitable challenges and sufferings of human existence. Not an escape from them, but a capacity to hold them within a more spacious awareness, to experience them fully without being fully defined by them, to know yourself as the unchanging background of all changing experiences. This capacity doesn't come from intellectual understanding alone, from merely thinking about consciousness or contemplating cosmic reality. It emerges from direct recognition, from first-hand discovery of what you fundamentally are through practices that shift attention from the contents of consciousness to consciousness itself, from what appears in awareness to the aware presence, in which all appearances arise, unfold, and dissolve. These practices aren't exotic or complex, but involve simple yet radical shifts in how you relate to experience. Rather than being absorbed in the content of thoughts, emotions, and sensations, You recognize the awareness in which these contents appear. Rather than identifying exclusively with your physical body or biographical self, you know yourself as the conscious presence that experiences through these temporary forms without being limited to them. Rather than seeking meaning in external achievement or validation, you discover it in the simple, profound fact of being conscious, of being an aware presence through which the universe knows itself. This recognition isn't something to be achieved in some future moment, but is available now in this very experience, in the awareness reading these words. It's not a state to attain, but what you already are prior to all attainment. Not a goal to reach, but the starting point of all seeking. Not something to become, but what you never cease to be, regardless of what else changes in your experience. And, in discovering this, in directly experiencing your nature as conscious awareness, rather than merely thinking about it conceptually, perhaps you find what the spiritual traditions have pointed to as enlightenment or awakening. Not a special state or extraordinary achievement, but simply clear recognition of what you already are, what you can never not be, what constitutes the unchanging reality of your experience amidst all change and transformation. This recognition doesn't require belief in any metaphysical system, adherence to any religious doctrine, or acceptance of any philosophical framework. It's available through direct investigation of your own experience, through first-hand discovery of what you fundamentally are beyond all conceptual categorization, all theoretical modeling, all narrative construction. It's what you already are, what you can never not be, what constitutes the unchanging background of all changing experiences. And in recognizing this, in directly experiencing your nature as conscious awareness rather than merely thinking about it conceptually, perhaps you discover what the philosopher Wei Wu Wei called the open secret, a truth hidden not by its obscurity, but by its obviousness, not by its distance, but by its proximity, not by its complexity, but by its simplicity. The secret is that what you seek is what you already are. What you're looking for is what's looking. What you hope to become is what you never cease to be. This open secret isn't opposed to scientific understanding of cosmic evolution or philosophical reflection on existential questions. It complements these approaches, contextualizing them within a recognition that all knowledge, all understanding, all questioning occurs within consciousness itself, within the aware presence that is your fundamental nature, the background of all experience, the reality prior to all conceptualization. And in this complementary relationship, this integration of scientific understanding with contemplative recognition, perhaps you find not a final theory that eliminates mystery, but a more authentic relationship with a reality that is simultaneously knowable through its patterns and mysterious in its depths, simultaneously comprehensible through conceptual thinking, and transcendent of all conceptualization. This authentic relationship doesn't pretend to have all the answers or to have eliminated all uncertainty. It acknowledges the limitations of human understanding, the necessary incompleteness of all our theories and models, the gap between conceptual knowledge and reality itself. But it also celebrates the extraordinary progress of human understanding, the remarkable capacity of consciousness to model the cosmos from within, the profound privilege of participating in the universe's self-knowing. And it suggests that the deepest truth, the truth about what's beyond everything, might not be something we discover through further exploration of cosmic expanses or quantum depths, but something we recognize in the immediate, direct experience of being conscious, of being aware, of being the presence in which all experience arises, unfolds, and dissolves back into the mystery from which it temporarily emerged. This recognition doesn't negate the value of scientific inquiry or philosophical reflection. These remain essential modes of human understanding, windows into aspects of reality that direct experience alone cannot reveal. But it contextualizes these approaches within a larger recognition that all knowledge, all understanding, all questioning occurs within consciousness itself, within the aware presence that is your fundamental nature, the background of all experience, the reality prior to all conceptualization. And in this contextualization, this understanding of scientific and philosophical inquiry as activities occurring within consciousness rather than explaining it from outside, perhaps you find a more integrated relationship with reality, one that honors both the extraordinary progress of human knowledge and the mystery that always exceeds it, both the power of conceptual thinking and its inherent limitations when confronted with the totality of existence. This integrated relationship doesn't provide the security of absolute knowledge or the comfort of final answers. It offers something perhaps more valuable: authentic participation in a mystery too vast, too complex, too profound to be fully captured by human concepts, yet intimately known through direct experience of being conscious, of being aware, of being the presence in which the cosmic drama unfolds. So I leave you not with definitive conclusions about cosmic reality, but with an invitation to hold the scientific understanding we've explored alongside direct recognition of your nature as conscious, awareness to complement third-person exploration with first-person realization, to pursue knowledge of cosmic reality while simultaneously recognizing yourself as an expression of that reality, knowing itself. And in this integration, this complementary relationship between scientific understanding and contemplative recognition, perhaps you discover not a final answer that eliminates mystery, but a more authentic relationship with the cosmos, one that acknowledges both the power and limitations of human understanding, both the knowable patterns revealed by science and the mystery that always exceeds our conceptual grasp. For in the end, the truth about what's beyond everything might not be something distant or hidden, but what you already are at the most fundamental level of your being, the aware presence in which all experience arises, the consciousness that constitutes your primary relationship with reality, the awareness through which the universe knows itself. And in recognizing this, in directly experiencing your nature as conscious awareness, rather than merely thinking about it conceptually, perhaps you discover what may be the most profound truth of all: that the seeker is what is sought, that the questioner is the answer, that what looks for meaning is itself the meaning it seeks. This recognition doesn't end the cosmic quest for understanding, the scientific exploration of physical reality, the philosophical reflection on existence, the existential questioning of meaning and purpose. These continue as essential modes of human engagement with reality, as important expressions of consciousness exploring its own nature through conceptual thinking and empirical investigation. But it contextualizes these activities within a direct recognition of what you fundamentally are beyond all conceptual categorization, all theoretical modeling, all narrative construction. It suggests that alongside the ongoing quest for understanding through science and philosophy, there's a complementary path of direct recognition, of knowing yourself not just as a physical organism or a biographical self, but as the aware presence, in which all experience arises, unfolds, and dissolves. And in this complementary relationship, this integration of conceptual understanding with direct recognition, perhaps you find not a final theory that eliminates mystery, but a more authentic relationship with a reality that is simultaneously knowable through its patterns and mysterious in its depths, simultaneously comprehensible through conceptual thinking and transcendent of all conceptualization. This authentic relationship doesn't pretend to have all the answers or to have eliminated all uncertainty. It acknowledges the limitations of human understanding, the necessary incompleteness of all our theories and models, the gap between conceptual knowledge and reality itself. But it also celebrates the extraordinary progress of human understanding, the remarkable capacity of consciousness to model the cosmos from within, the profound privilege of participating in the universe's self-knowing. And so, as our exploration truly concludes, I invite you to hold this paradox, this creative tension between knowing and not knowing, between scientific understanding and contemplative recognition, between conceptual thinking and direct experience. I invite you to continue the quest for understanding through science, philosophy, and personal inquiry, while simultaneously recognizing what you already are beyond all seeking, all questioning, all conceptualization. For in this paradox, this creative tension between ongoing inquiry and present recognition, perhaps you find not a final resolution that eliminates mystery, but a more authentic relationship with a reality that always exceeds our conceptual grasp, even as it reveals itself. Through our scientific and philosophical explorations, through our direct experience of being conscious, of being aware, of being the presence in which the cosmic drama unfolds. So I leave you with one final thought, an invitation to continue the exploration on your own, to pursue understanding through both external investigation and internal recognition, to seek knowledge of cosmic reality while simultaneously discovering what you already are at the most fundamental level of your being. The universe may have no edge. Reality may have no ultimate boundary. Existence itself may be fundamentally mysterious, always exceeding our conceptual grasp, even as it reveals itself through our scientific and philosophical inquiries, through our direct experience of being conscious. And perhaps this boundlessness, this edgelessness, this inherent mystery isn't something separate from you, but what you fundamentally are. The aware presence in which all experience arises, the consciousness that constitutes your primary relationship with reality, the awareness through which the universe knows itself. The universe may have no edge, and neither do you.